participants at all the centers. Uh, Today we are going to start with our normal topics on building repair and maintenance. Uh, I hope that at all the centers the participants they have joined, and we will be having today 3 sessions starting right now, followed by another session at from 11:30, and then final session will be from afternoon after the taking the lunch. Uh, for this session, we have with us Dr. Vrinder Kanwar. Uh, he is presently a professor in civil engineering and registrar of the Chitkara University, Baddi, which is one of the leading private university in this part of country. Uh, and he has got a vast experience and very widely traveled in different countries, and has guided many research students under him, both PhD level and MTech level also. He has been he worked in Thapar University also as professor, and then as registrar of Punjab Technical University. And then since after this university in Baddi came up, so he has been looking after the that Baddi as a registrar and also as a professor in civil engineering. And his work is basically on how to monitor the health of the structures, and it is a very important area, because we uh, as we see that okay, our buildings, our structures, they are deteriorating, and we have seen many times fatal collapses also, uh, maybe due to the not regular monitoring of those structures. So we need to know that okay, how we can have regular health monitoring of our structures. So from this point of view, this topic is very important. So I will thank Dr. Kavar for accepting our invitation to deliver a talk in this particular topic, and he has been otherwise a regular faculty to our various programs, and we have been uh, as a institute partner, we have conducted many times many say conferences together also, in which their contribution is again very important from that aspect of view. So I welcome you again, sir. And
Yes, sir. So give me your TeamViewer ID and password. TeamViewer, sir.
Thank you, Dr. Sharma, for your kind words. Yes, it's true that we human beings we are also like a structure. Our structures are also Start from. Thank you, Dr. Sharma, for these kind words regarding me. Today, I'm going to talk about the health monitoring of structures. As the topic name depicts, we human being, we are just like structures are also like us. That we have to monitor their health, we have to monitor their maybe well-being, and then they can perform much better than as we human being are. So today, I'm going to present this structural health monitoring. What is structural health monitoring? Then I will give you a case study where how we can actually do it and how we can predict the remaining life of a structure, which is a very hot and burning topic these days. So in this presentation, basically, I'm going to cover the definition, what is structural health monitoring, pattern, importance, and then components. And finally, I'll end up with a case study so that one should know how we'll do it. This is the actual case study which I'll present to you. So basically, what is a structure? Structure is a combination of foundation, basement, column, beams, and slab. And damage in the structure is because of mismanagement, because of poor quality control, the temperature condition, and sometimes the long-term behavior which can lead to the cracks, segregation, and settlement, that type of failure. So structural health monitoring, we can say that it is a real-time analysis of a structure. What are its parameters, and with the passage of these deterioration, what happened to the structure, maybe after 10 year, 20 year, or 30 year, or maybe 100 year after this is over. So purpose is main and most important purpose is the safety one. Safety, and safety, because in India or in many part of the world, we have the mechanism where we are constructing the new construction or new buildings without following the proper procedure or the proper code. We in India, just like after Bhuj earthquake, we felt that most of the buildings in the rural areas, they were constructed as without following the seismic procedure. So we want to ensure that there should be a procedure, there should be a system to know whether this building is properly constructed or not. And then second, provide maintenance and rehabilitation advices. If suppose the disaster occurred to my building, now what is, whether I can use that building after say this disaster or not, or I have to vacate that premises. So that is the second purpose of doing the structural health monitoring. Then design guidelines. Suppose from my study, if I can give or if I can suggest something so that future engineers, future designer, they can incorporate those into the design, the health monitoring purpose is also that. Then finally, the disaster mitigation. Many times it happens that the structure which feels to be the safe one without any crack actually have so many cracks in it. So we want to avoid those type of situations, we want to avoid those type of disasters, so that in future that building should not collapse after the earthquake or after any calamity which is there on that structure. Then at present, what we are doing, our health monitoring, we are doing it localized way of doing those health monitoring. And then what at this moment, after that Bhuj earthquake, we are over designing the structures, means we are consuming a lot of material like steel, like concrete. Then damage tolerance, we are designing for say earthquake resistant design, even if the building is not situated in the area where a lot of severity of earthquake is there. Then life prediction, at present we are saying that the building life is say 100 years, so we should not use it after the 100 years. After 100 years, this is as per the designer, but actually it is not happening. Then quality control, yes, we can increase the life or we can reduce the risk of the failure if we have a good quality control over the material as well as the manufacturing process. Then accurate specification of operational condition, like we should know actually in which part of country this building is situated, how is the temperature or how the weather is going to behave, means what is the maximum temperature, what is the minimum temperature. So if we can predict it accurately, we can increase the life of a structure. Then periodic inspections, we can do it. Manual non-destructive evaluation, because nobody will allow us to do the testing in the destructive way. So now we have formed, or we have developed a mechanism to know the actual strength of a structure by performing various tests with the non-destructive testing, like hammer test, ultrasonic pulse velocimeter, and all those type of stuff is there. So the question is, if we have all these mechanisms available with us, then why we require this health monitoring of structure? So the answer is health assessment for increased service life. Nowadays, in a developing country like us, we can't take a risk, or we can't say that now this building is have attained its life, so please go out or go away from here and dismantle this building, we will construct a new one. Neither the owner nor the government is having that much money with them, because most of our important structures as well as railway bridges, they are more than 100 years old, or they are about 100 years old, and we don't have that much money available with us where we can do the thing, we can take out the existing and fabricate the new one or construct the new one, which is not possible in a developed country like, or developing country like us. In developed it may be possible, but in developing country like us it is not possible. So we want to know how much is the remaining life of this building after the normal service life of that building. Then if suppose the load increases from the load which we have calculated, what will happen to that building? Then condition assessment for the aged structure, like I told you, the important monuments or the railway bridges or the other bridges which have attained their life, but we want to know that whether we can use it still further or not. So that type of thing we can only check if we have the structural health monitoring practice in place. Then life extension beyond design life. I designed a structure for 100 years, whether I can use it for 150 years. So that certificate is to be provided by the inspector or by a person who is doing the structural health monitoring. Then experimental verification of the design procedure. Whatsoever the design procedure we follow for construction purposes, whether we are going to give the actual building as per that or not. So that is also the need for a structural health monitoring. Then what is damage? If we call damage is the change in the geometry, boundary condition, or system connectivity. Basically, in a structure, if any one of these three they are changed, we can say the geometry of the failure of the building is there, and there is a chance that the building can collapse. So which adversely affect the structure performance. If any of these three conditions there is going to have a problem, the structure can be of no use to us. So now if damage is there, how to know it? This is a very old concept. We were using it since past. We may be recollecting nowadays, although earthen pots, they are not very familiar, or they are not being used in common practice, but whenever you go in a market to buy an earthen pot, you can check its crack by simply striking it with the finger. So the sound, the vibration, or the intensity of the sound can give you an idea whether there is some crack in that building or in that pot or not. So same concept is applicable to the building also. When you are giving some vibration to the building, if there is no crack in the building, the sound or the record which you are getting from that is going to the different one. If there is a crack in the building, the quality of the sound which comes back is going to the different one. So we are using the same concept here also. So the other these concepts, but problem with this is you cannot go inside the structure. Every part of the structure is not accessible, so you cannot go there to know whether there is a crack in one corner or in other corner. So it is a very tedious type of process. So we have to find out some ways how to find the cracks in each and every corner of the building. If there is a failure in one corner, this will have a failure of whole building, because only if one settlement of the column is there, the whole building can collapse. So this is not localized type of damage. The localized damage can lead to a devastating failure, or maybe having a very severe type of failure. So what we can do then? These type of things are there, so we want to have a smart type of system. Smart system, we should have sensor embedded in those structures. Those sensors should check if any failure is there in those buildings, but that is possible only when you are constructing the new buildings. The new, you can use these type of techniques, because in the developed country like Japan, or maybe in US also, we have on each corner sensor embedded on the beams or on the column or on the footing. Those sensors are going to give me the continuous data of the performance or behavior of that building. So I need not to worry, because my computer is going to conceptualize the things and then record that data whenever I require to know what happened when this earthquake of this intensity it occurs. So that time that data is available with me on the computer. I can take that data, I can check, I can use that data for further calculation. But this is not possible for the older buildings. For that we have to find out some mechanism, because new you can change, but what will happen to the buildings which already were erected 100 years back and not properly followed the various codes in those buildings? Then I'll say that this checking of the structure is a biological process. Like we as a human being, we are observing, we have sensors, like sensor in human, we have ears, we have eyes to see. Similar is the case with this structural health monitoring also. And as a human being, I have the mechanism of giving a load to the human, and that load carrying capacity of a human is also different one. If suppose I can carry a 50 kg load without failure or without yielding, the structure is also having the same type of concept. So I have to find out the ways how I will check my structure. I have to find out the ways that how I can improve the performance of a structure. So it is structures and human, as I am telling you since the start, they are very similar to each other. My building is also going to also going to take the load for which I have designed it. If I exceeded that load, the collapse is going to be there, like a human being. So there is a quite similarity between a building and a human nature. So what are the objective of structural health monitoring then? By seeing all these slides, I'll say my objective is first to determine the damage existence. I want to be sure, doubly sure, whether there is any damage in the building or not. Then determination of the damage and its geometric location. If damage is there, on which part of the building this damage exists. Then quantification of the damage severity. If suppose damage is there, whether it has affected the building 10%, 20%, whether this damage can be we can overcome, or we can do some rehabilitation, or we can have some technique where we can strengthen if suppose damage is less. You have a technique where you can strengthen the damaged column beams if the damage severity is less, but that is only possible once we are sure that once we can quantify the damage. Then prediction of the remaining life of the structure. So these are main 4 basics or 4 objectives of the structural health monitoring. So how we will do it? Pattern of structural health monitoring, we will say operational evaluation, data acquisition, feature extraction and data compression, and then statistical model for development of feature discrimination. So I'll explain each one by one. What do you mean by operational evaluation? I have to find out under which load the damage is going to be there, whether because I designed it for say a particular type of live load or a design load. If suppose you have put additional machine on that, so it has increased that load. So operational evaluation, I have to find out that if damage is there, what are the factors which lead to that damage, or why the damage happened in that building, because you must have increased the load. That is the one possibility. Then life safety and economic justification of performing the structural health monitoring. Yes, this is true that cost is involved in this structural health monitoring, but we have to say that this cost is not of that much intensity if you can increase the life of a building for say 20 years. So that justification we have to give, because many times it is very difficult to tell or to make it convenient or to maybe justify this thing that yes, this additional 10 lakh or 20 lakh of rupees is not that much, but you get your structure properly checked up by doing structural health monitoring. It will increase, or it will have a safer side of yours in the long run of that structure. Then limitation of acquiring data in structural health monitoring, because as I told you that structure is a combination of thousands of different component, or you can say lakhs of component. You cannot access every part of the structure. So there are limitations that you cannot access every part. So we have to, that is the operational evaluation. We have to find out that what are the things, what are the operating things which we can evaluate so that we can predict the health of a structure. Then data acquisition. Now we have, or we know the procedure. Now we have to acquire the data. Data acquiring is also very, very important, and this is the main, because if you acquired a correct data, you can predict the correct life of a structure. But if your data acquisition system is not up to the mark, or if you have the various other type of problem or various other type of noises which are coming along with the data or in the sensor uh, which are taking the data, we have a problem. So we have to find out for data acquisition how many sensors I required, what type of sensors I require, selecting their excitation method, because sensors are not going to get the data unless and until we are going to excite the building. So excitation method is also very important. Then data storage techniques, because you have a enormous quantity or huge amount of data available. How you can store that data, because data acquiring is not a problem, data utilization after acquiring is also a problem. So we should know which technique I should use, where I should store my data. So that is the data acquisition technique. Then data normalization. I know this data when it is coming. This is coming along with various other unwanted, or we have various noises near around the building where I am acquiring the data. So I have to normalize the data. I have to take out the unwanted thing from it. So that is called as data normalization. That is separating changes in the sensor reading from damage to those caused by the operational and environmental condition. If suppose you are performing structural health monitoring, there is a wind which is blowing at a speed of 20 km/h, you have that type of interference or problem in the data which you have acquired. So we should know how to take out this unwanted data from the data which I am interested in at. Then feature extraction. Feature extraction give a technical literature or a reading for distinguish between damaged and non-damaged item of a building. Means in a column I have three different locations. The sensors are there at three positions. One sensor will give you one data, second sensor will give you the second data, third is going to give you the third data. If there is a damage, all three data will be different one. But if there is no damage, the data is going to the same one. So I have to find out that this data of the damaged and undamaged building should be the different one. Then finally we have to find out or work out with a model so that this data can be used to predict the life of the actual or already constructed building one. I'll clarify all these things when I'll show you the actual case study on a building, and then we predicted the data, or we predicted the life of a actual structure and the remaining part of it. Then so finally we will say that the core component of a smart structure system is having the following elements, that is sensors, then data, information processing and interpretation, and then controller and actuating devices. So this is a theoretical background of this structural health monitoring, but the actual the practical I am going to now show it to you, that will clarify and that will give you an exact. So structural health monitoring can be carried out by various techniques. Here I am telling you a technique where the vibration measurement, and that is the most convenient and most widely used technique used in most of the country nowadays, because vibration measurement, as I told you, this is a old concept, and now we are just revising those things, and we are maybe more focusing on the scientific part of those. The main hypothesis we know, now we have to elaborate those things, because that is, if damage is there, the sound quality will be different one. If no damage is there, the sound quality will be the different one. So that is the vibration measurement, and how we will perform it I'll explain in the next slides. So why, when we started this work, at the time Bhuj earthquake was there, all the magazines, we are having the cover photo of the building collapsing and all those things. So at the time we thought that yes, it is not in our hand to predict whether this damage is going to come or whether this natural calamity is going to come or not. We cannot predict that. But after that natural calamity, God forbidden it, if it occurs to my building, whether that building now is safe or not. So that is the motive behind this study. And at the time, not much work was done on the structural health monitoring when we carried out this study in the year of around 2003-4, and now we are continuing that study since then. So all these type of pictures were there. So why we thought, as I told you, that there were several methods which are based on the measurement, change of frequency, change in mode shape or other structural property before and after earthquake. I know there may be some of the participant who are hearing me. These terms are very common if you are a designer, because when you test a structure, normally the structural inner component, or there is a shift in the mode shape, there is a shift in the frequency, there is shift in the time period, and all those type of stuff which we call as dynamic properties of the structure, if there is a change or if there is a damage in the structure. So we were having lot many techniques available, not here in India but used in the other countries, to know down or to know the damage which occurred in that structure. Then many of these damage detection and evaluation techniques were on the basis of visual inspection. You go, you see that room, if there is a crack, we will say structure is unsafe. If crack is widening, we will say yes, take all the occupant of that building out, otherwise the building can collapse. But those were the localized, or those were the visual inspection, and the techniques were also the just normal techniques, not a scientific technique. Then these methods are often inadequate because of their inability to detect visual or internal damages. As in the earlier presentation also I told that we have different component of a building where you cannot access every part of the building. So you have to find out a different way. Then there are numerous instances in which the building which looks to be the safe one, but actually it was severely damaged. So these were the gray area which leads to our this research. But we thought that let us try to find out the solution for the problem which I focused here, or which I jotted down here, that are the main 4 problem areas. So then we thought of doing some maybe first modeling, then testing, and then testing on the actual building. So why we require it? As I told you that we were having most seismic region in the world where old buildings were originally built with inadequate seismic resistance constitute. These all were the same one. We were having the problem with this. So vibration measurement are thought to be the sufficiently sensitive to detect and monitor damage. Vibration measurement. So what were objective? Our objective were also the same one. First, experimental, that is determination of the dynamic characteristics of the model of the framed reinforced concrete building under different level of damage. Then experimental estimation of the dynamic characteristics of the existing reinforced concrete building, and then establishing a correlation between the damage in a model of the damage of the reinforced concrete building with its known dynamic characteristics using artificial neural network. And then finally is to develop a methodology of damage detection and health status using vibration measurement techniques. So what this means? This means that I want to be doubly sure. So because this type of experiment, if you want to perform in the lab, it requires lot much money, and you have to make a frame, you have to test it, you have to demolish it. So cost was involved. So before going for actual experimentation, we first thought for going for an analytical model. That is, we thought for going for a frame structure, and we did the analysis of it in the software, and that was just, we say that it is a analytical investigation of that. Once those results give us an confidence, then we thought for going with the actual experimental part in the lab, and then those experiments we repeated in the actual field also. So this scope, but because whenever you start your study, you cannot cover the whole type of structure. So we studied only RCC, and then we studied only 3-story. Then the damage has been induced in the building model by applying horizontal load, because you are having different way of giving a damage to a model. So we thought we should give a damage by applying a force horizontally, and that too at the top of a model. I will show you the things in the picture also. Then damage detection for various actual building, that is the 3 scope areas of my study. So if suppose you are designing a building now, you are erecting a building now, you can, I told you, you can put sensor in that, you can have the data acquisition system, and you can study its behavior throughout its life. But what will happen to the earlier constructed building? Because what is health monitoring? Today I am suppose 40-year-old. What should be my parameter when I was 20-year-old? And what is going to be my parameter when I am going to be 60-year-old? So that is the comparison. Health monitoring is the comparison between the previous at this moment and what will going to happen after 20 years down the line. So now if you are constructing now, so that building we have the initial record, but the building which was constructed 20-year back or 30-year back or 50-year back, I was not having any of the parameter of that building at that time. So to predict the parameter of the building which is constructed 30-year back or 40-year back, I have to find out, or I have to devise a mechanism where I can give you an idea that what should be its frequency, what should be its time period, what should be its mode shape 50 years before. Although I am not having that actual data, but I can predict that data. To predict that data, I have used that artificial neural network modeling, which is a tool which can give you an exact prediction of the data of a building which is maybe constructed 50-year or 100-year. Means since we are not knowing the exact position of the parameters which is constructed a way back. Then this ability of the neural network approach is to train a given set of data on the basis of predict missing data, also to achieve possible normalization, makes it an attractive proposition for the knowledge acquisition of the problems where there is no acceptable theory or empirical generalization. So because of this versatility of the artificial neural network modeling, it has been used in the present study. So I told you that we started with the analytical. So for going for the actual one, we started with the analytical. In the dynamic characteristics of a building are obtained analytically by different level, by giving the different level of damage, and the neural network is used to find out the correlation. This is the model which we constructed with the help of which we maybe drawn or within the software, and we did the analysis of this model. The damage index, you have to say that find out how you can predict the damage. For that I require a damage index. Damage index can be devised by different researcher in their own way. What we did, we say that what is the damage today and what is the damage 2 years back. So that difference between the two successive loading conditions, they are going to give me the damage index. So in this case, when we are going with the model in the computer, so there the flexural rigidity is the main component, that is E and I. But when we talk about the I, that is moment of inertia, we normally say that if damage is there, if small damage is there, the I property will not change. So we are left with the modulus of elasticity only. So we change that value. So by changing this E value, the flexural rigidity also change, and then we will be in position, or we were in position to predict or to say the damage is there in that building. So we studied this and we found almost 11 patterns. So you will see here E value in the earlier pattern when there is no damage. What is the this mode shape coefficient, story drift, and this frequency, everything we can get from the software part. When we do the analysis of any building in the software, you can get these dynamic property of the building also in those softwares. So how we can give a damage in the software? The damage we have given in the software by reducing the value of flexural rigidity by decreasing. Initially you can see that here in the top story, this damage, the value of E is 2 into 10 to the power 7, but you started giving damage to the top story, then the bottom story, then the middle story. Similarly, how much is damage you have given, that is a reduction in the value of E. Initially if no reduction, then you can see the mode shape coefficient, story drift, and the value of damage index. When reduce the value, the changes is there. Initially 5% reduction is there in the top story, then we reduce the top story by 10, second story by 5%, and we go like this only. Means 11th set is we did reduction of the flexural rigidity at the top story by around 50%, middle story by 45%, and bottom story by 40%. So this gives us the damage. So we say that the top story was damaged by a force around 50%, which is there, and then the damage in the middle story is around 45% damage is there, and at the bottom we have given a damage of around 40%. So if you see this table, you will find out, or you will see that the changes is there in every value, whether it is frequency or whether it is a damage index. So now this is a value which is given to me by the software. So I used my artificial neural network to train my network on these, because now the building which is 100-year-old, I can use this network on those buildings also. So what we did in the neural network, what you can do, you can have an input parameter and you can have an output parameter. I have taken this story height, mode shape coefficient and frequency as a input parameter, and I have taken out I have said that damage index will be the output parameter. So what in neural network you do, if suppose we have taken the 11th set of pattern, out of those 11 I use 7 set for training purposes, and I predicted the damage index of the 4 one which we have not set for the training one. Means prediction is done for the 4 one which is not given to the neural network for training purposes. So this is a very good way of predicting the life. Means here 4 patterns were skipped from the total data of testing, and patterns number 1, 2, 3, 5, 7, 9 and 11 were given in the table above have been used for the training. So what result? This is a result. You will see that these are the 3 dots which you can see on this graph, and one color is going to give you the actual value of damage index, and the second value is given by the neural network. So you will find that those two values are in very close proximity with each other. So that gave us an confidence that yes, we can predict the data for those readings also which are not available with us. So here you can see from this graph that my neural network were in position to give me the correct value of the damage index which I have not used for the training purposes. So it can be seen from these plots that the predicted values of the damage indices are observed to be the same one with the corresponding value of the damage indices used for the training of the network. And if the difference between these two values, if it is less than 10%, we will say that ANN prediction is accurate. So then we got a confidence. We published a paper based on this study. That paper was published in a leading journal. Then we started with the thinking of actually casting that model in the laboratory. So we went to the lab and we casted this reduced version of 3 by 3. This total height of the model was 3.3 meter. Floor area was 2 meter by 2 meter, and we made 3 story of these. Slab thickness was, this was the reduced version, and we used the M25 grade of concrete for casting it. This is the picture of that model which we have casted in the laboratory, because it resembles with the actual one, or it resembles with the analytical model. So that is why we casted that type of structure in the lab. Then this is how you can give a loading. On one portion you can see there is a jack that is called as hydraulic jack, and on other side we have the sensors and we have the strain gauges which will give me the deflection, because we are going to give the load from one side and we are going to observe the behavior of the building on the other side of that building. So we have put the sensors as well as the strain gauges on the opposite direction of the load, where we have given the load and where we have the sensor put on the building. So this type of frame we constructed in the lab, and this was the second model which is there with the infill wall, because you have different mechanism, you have different type of building. Like in the basement you don't have you have only the parking area, we don't have the infill wall over there. So that type of building, that type of model can give me the idea of knowing the health monitoring of a basement floor where you have the parking slot, and this infill wall will give me an idea where I can check a building which are having the partition wall or which are having the walls in it. So these were the instruments used. Here you can see we have the impact hammer which was used to excite the building, and then we were having the FRF, that is this data acquisition system. This is FFT analyzer which is going to collect the data Means I am going to excite the building with the impact hammer. The sensors which are placed opposite to that hammer are going to check or are going to note down the readings, and those readings are ultimately going to come in the data acquisition system, which is, we will say in this case, FFT analyzer. So this is the actual how you then data acquisition system is to be linked with the laptop. And one here this figure is also going to give you the type of loading frame we used for this purpose. This is we were having the 16 channel this FFT analyzer, where we use the sensors and we placed it on the opposite side of the load. So how the instrumentation done? The accelerometer were attached to the model casted in the laboratory, the impact hammer used to excite the structure, then the signal from the accelerometer transferred to the data acquisition system, that is FFT analyzer, then dial gauges were used in each floor to give you the deflection also of that model. Test cases, experiments were carried out in the undamaged and the undamaged state. So what happened? Initially, the building or the model which we have casted, it was not having any type of damage in it. So that is going to give me the value of the undamaged structure. I performed a test. I have given a load or I have given the excitement with the help of impact hammer. I noted down the reading of the sensors in that undamaged model. Now the second case is I have applied the load with the jack, maybe that 5% load applied, 1 kilonewton, 2 kilonewton. I'll give you the table also how much load I have applied. If I apply a load to a building, it induces some amount of damage in that. So when it induces some amount of damage in it, the property of that model is going to change. So initially it was without any damage, then we applied the load through the jack, we take out the jack, we applied the excitation by putting impact hammer and then taking the reading of the sensor. Similarly, by increasing the load, we have gone from a undamaged model to a totally damaged or totally failure state of that model. So this is how we have given the, so load is applied at a uniform pace rate and then load then removed and calculated the dynamic characteristic. Because if you have given the load with the help of a jack, and if jack is there in that position, the excitement will not be there of that model. So we have to remove that jack and then finally excite the model by using impact hammer. Then sensors are going to give you the value of those. This is a just a 3D view of the model. This actual model, the 3D view of that, to give you an idea where we have applied the load and then excitement is there, excitation is there on that point only, and opposite points we have put the accelerometers or the sensors which are going to take out the value of the dynamic properties of that model which we have casted in the lab. So from here you can see the top, when there were no infill walls, the maximum damage were there in the top stories, and this is going to be validated by these actual pictures also. I'll give you the actual pictures. But when there is infill walls in the model, the maximum damage was there in the bottom positions where there were no infill wall. So this is the actual practice also. So my model also behaved the same way. So it gives me an confidence that yes, our study was going in the right direction. So this is there the model without any infill wall. There from the picture you can see the maximum damage was there in the top stories. And this is the second picture where the top story was intact, but the maximum failure was there in the bottom stories because there was no infill wall in the bottom portion. So that is why the maximum damage was there in the bottom story. So these, and here also you can see where is the foundation, also the damage was there because the strength of the bottom story was weak. So load deformation history, when I calculated, it comes like this. So now the thing what we calculated, I told you that we have the dynamic properties of the structure. In dynamic property, we mean to say we can check its frequency, we can check its time period, we can check its damping, we can check its frequency response function. So you can choose any one value out of it for your study to calculate the damage index. Because damage index is what? The change in frequency from no damage to 5% damage, from no damage to 10% damage, from no damage to 20% damage, that is the damage index. But in this case, rather than frequency, I have chosen this frequency response function, which we obtained from this data acquisition system as a method to calculate the damage index. The value of the frequency change in a building, because building is a huge structure, the change in frequency is very less. If suppose initial frequency without any damage is 5 hertz, then if there is 10% damage, you may find the change in the frequency is just 4.9 hertz. Means you are not in position to give the exact information by, if you want to take the frequency as a parameter to calculate the damage index. But in frequency response function, we are getting that value which is a reasonable good one. Like frequency response function here, if you can see, at 5 kilonewton load, the at no load frequency was 11 hertz. Frequency response function magnitude was the 38 G per Newton. So frequency response function means what? You are giving force excitation by impact hammer, which comes in the form of acceleration, or force in the form of Newton, and then the sensors are going to take the data which is there in the form of G, acceleration. So that is frequency response function to the frequency, how it is going to behave when we are giving a force to that. So frequency response function magnitude was changing a lot. So you can see here, initially it was 38, then with the 5 kilonewton load, this reduces to 30.5. so there is a shift in that, around 8, but in frequency shift is there only 0.5. So that is why we have chosen frequency response function to calculate the damage index. More damage you are going to give, the value of frequency response function is going to change, as well as frequency is also going to change. So at 25 kilonewton, you can see frequency change from 11 to 9, whereas frequency response function magnitude changes from 38 to 6.9. So this can give me a good value where I can predict the damage in a better way. Then similarly at 30 kilonewton, 35 kilonewton, so that was the FRF magnitude without infill wall. Now for the infill wall also, you can see here the differences. When there was no damage, the FRF magnitude was 38, frequency was 11. But when there was totally damage, the building was collapsed, the FRF magnitude reduces to 0.44 and frequency reduces to 3 hertz. So this is also the time history response. The undamaged building is going to give a very good dying down curve of this frequency response function time and this frequency. So you will see here, when there was no damage, the damping, and when damage started, the curve, it is going to maybe elongated. So you can see here at 25 kilonewton, initially the curve was very good, and then in 25 kilonewton you can find this curve, or you can see this curve which is there, a very widened one, and damping was also more. At 35 and all, this is then undamaged to the damage story. So if you want to see a correct picture of all the three story, you can see here from the sensor 1 where there was no damage, FRF magnitude was 100. In sensor 2 partially damaged, FRF magnitude was 30.5. In sensor 3 where it was totally damaged story, the FRF magnitude was 24 G per Newton. So this will going to give me an idea that yes, I can find out the frequency response function of different stories which are there without any damage and which are there with the damage. So damage index, I told you that we have taken the frequency response function. So the difference between the two value minus the initial value, that is going to give me the damage index Fi and FDI, that is initial frequency response function and the damaged frequency response function, the difference between two divided by the initial value. So that is going to give me the value of damage index. So this type of then reading I can get from the data acquisition system. So you can see here at 0 kilonewton load, this is the result without infill wall. At 0 kilonewton load, when there is no damage, frequency was this. At 15 kilonewton load, the cracks appeared at beam column joint of the roof level. So this predict, or this is going to be validated by the actual model which we have casted and actual cracks which we were seeing in those models. So at 40 kilonewton, model stops taking further load and totally damaged. So you can see there is a change from 11 to 3 in the frequency, FRF magnitude from 38 to 0.44, and deflection from 5 to 54. This is the sway which is going to take place in that model. No strain and the final strain. And then time period, initially it was 0.09, then the time period was 0.33. Similarly damage index. So you can see from here in undamaged, you can now find out the damage in a binary term, like 0 no damage, 1 is the maximum damage. So my damage index value can give me an idea that there is a crack in the building or no crack in the building. So here also you can see that the damage index above 0.5, the cracks started appearing in the building. So 0 to 0.5, if the damage index is there, we will say that yes, your structure is safe. Your life of a building is still, you can use that building for maybe 10 more years. But if your damage index value is between 0.5 to 1, it means that there is a problem in that building. You have to take out the habitants of that building out, or you have to do some mechanism to repair that building. So this is how the time history records when there is no load, when 3 kilonewton load, 7 kilonewton. So you can see the shapes here. Initially very good shape like this, a very good, you can see a proper sine curve. But when we are going to increase the load, the shape of the time history response curve is going to change. So this is the second case, that is when infill walls were there. So the frequency and frequency response function of those. And similarly all these graphs, I'll show you a table where you can get a value. So here also at 0 kilonewton, the frequency of the building was 8 Hertz, frequency response function magnitude was 185 and all other parameters were there. So with the increase in the load, the value were started decreasing, and then from 8 frequency, the frequency reduced to 6 hertz, and the frequency response function magnitude reduces from 185 to 52.5. And actually also the building stopped taking any load, and cracks originated in beam column joints at first floor. Then finally when it totally collapsed, that is at 72 kilonewton, the frequency changes up to 3.8, and the frequency response function magnitude, it reduces up to 1.05. So total failure of the beam column and the base of the RCC frame in this case. Now we thought that let us go and try this, because this was the thing which we tested in the lab. So lab testing is of no use unless and until I can use this study for the actual building. So these are the pictures of the actual building. I have chosen the picture which were there almost of the similar nature as that of my model casted in the lab. So there I checked those 4 buildings. In those 4 buildings, 3 buildings were without any damage, 1 building was totally damaged. So we've again used the same technique. Here you cannot give any force. So we just used our visual inspection, because if there were cracks, we thought that some damage is there in those building. But we use the impact hammer to excite the building, and we use the accelerometers or sensors to take out the dynamic characteristics of that building. So like the earlier 3, these were the newly constructed. So we can differentiate only when we were in position to know that whichever the newly constructed and which were the building with the cracks. So these were the building with cracks. Now the value of the results of my data acquisition system are going to give me an confidence that yes, I have predicted the value of the damage correctly. So here also I found out various like frequency response function, frequency, time period, and all those type of stuff from the data acquisition system. And finally this is the tabular form of that results. Here you can see building number 1, 2, 3, 4 and 5. In the 1 you can see the value of damage index, and where the building number 6, this was the building number 6 where you were in position to see the actual cracks, the damage index was 0.9. So by this method I have predicted that yes, failure is there in that building, and actually also in the building which were newly constructed the damage index was very less, but the building which were old, like in some of the building, like building number 3, the damage index was 0.5. So that was a building which was constructed around 30 years earlier. So but in that building, when I come to know from the owner, yes, they constructed it with the help of mason only. They have not used the proper design procedures to construct that building. So we found that in that building the damage index was 0.5, but the building where the cracks were available, we can in position to check, or we predicted the actual value of the damage index, which was 0.9. So similar type of stuff we can use in predicting the behavior as well as the residual life of the bridges of the old buildings, where you are not having the initial record. Initial record are taken by your neural network with the help of same type of model casted in the lab, and then finally the failure can be taken, or finally the record can be taken of the present situation of that building by going actually to the site, and then knowing down the damage index or finding out the damage index. So since this is what we say that ANN was used to know the earlier characteristics of that building. So data obtained from the experimental studies of the building model have been used for testing the network. Damage index has been taken as an output parameter, and the network is trained for the frequency response function. The training is carried out in the data set and predicted the damage index. So this is the correlation between the predicted and the experimental value. So we can conclude we concluded in this study like that the verify the feasibility of using vibration test to assess the condition of reinforced concrete structures. We did it. Tests have been conducted on 2 reinforced concrete building model on the same some exciting existing RCC structures. The deflection and acceleration time history response after exciting at different point of the building model are recorded, and finally the changes in the dynamic parameter like frequency response function and damping are correlated with the damage from the preload stage to the fully damaged state. Further, using the neural network, the correlation between the damage in the building and its known dynamic characteristics is developed, and then we finally come out with a methodology to predict the health of the existing structures. So main conclusion, the natural frequency of the building model reduces with the increase in damage. At a stage of total collapse, the reduction of about 70% of the original value of the natural frequency has been observed. Frequency response function magnitude also decreases, and large reduction in the frequency response function was observed. So all these, and then fifth point, which is very much of very much importance, the damage index for the different level of damage as calculated from the frequency response function magnitude indicates that the damage index increases with the increase in the damage. On 0 to 1 scale, if suppose damage index is 0, there is no damage, and nearing to 1, it was our model was fully damaged. So here also I told you in the actual model, actual building which we tested, the damage reduces from 0 to 0.98, and building where the damage index was 0.5 looks to be the safer one. Up to 0.5 was safe one, and you can use those building without any problem. But the building more than with the damage index more than 0.5 to 1, we were worried about those building, and we can suggest some remedial measures, or we can even suggest that dismantling of those buildings can be done, and we can use the new in place of those buildings. So all these are the conclusion drawn from the study which we performed in the laboratory as well as on the actual buildings. So in the last, I can conclude by saying that there is always no particular conclusion for any technology related concept. But yes, this concept and with the conclusion with even structures have a life, and we civil engineers are here to protect it from the various diseases. So we should know, we should take care of the building as we are taking care of ourselves. If important, we can call an expert from the structural health monitoring side to come and inspect my building and tell me whether there is any crack in that. If suppose crack is there, we can take the response, we can take the remedial action immediately without any failure, because this will lead to a happy living in that building where we are staying at this moment. Or if suppose the railway bridge is there, because it involved huge money in constructing a new bridge, so those type of buildings which are of national importance, where the construction or reconstruction is going to take lot of time, lot of money. So we can use this technique to calculate how much is the remaining life of that building, and whether we should use that building, or we can dismantle it and we can fabricate or we can construct the new one in that place. So I hope I am in position to clarify so many things, but if suppose any doubt is there, we can open the house for discussion. I am happy to answer any query, any doubt from the centers. From any center, if any doubt, any clarification is there, we are there to solve those or to clarify those doubts. So if no doubt is there, we can close this session. And still, if you have any problem, any discussion, my mobile is there. We can circulate it from the knitter, and my email ID is also there. You can write to me on those email ID and even talk to me on those phones.
Hello.
Hello.
Hello. Good morning, sir.
Morning. Morning.
I'm Sachin Kulkarni here from Jain College of Engineering, Belgaum, sir.
Please come closer to your mic.
Yes, sir.
Yes,
am
yes.
I audible now?
Yes.
Sir, one query to me is, as you have
Yes.
mentioned about the damage index, is it the same as that of toughness index what you are mentioning?
Please repeat your question.
So damage index what you have mentioned,
Yes.
is it the same toughness index what has been mentioned in JSC?
No, it is not the toughness index. Damage index you can calculate, or it is your own way of calculating the damage index. Damage index can be worked out on the basis of frequency. It can be worked out on the basis of time period. Basically, it is the shift in those dynamic properties. What is
Okay,
the
sir.
time period earlier and what is the time period now? So I use the frequency response function in this case.
Okay, sir. So one more query, sir.
Yes.
Whenever there is a damage, the first propagation is nothing but the crack propagation.
Yes, sir.
So as mentioned in your analytical study, you studied what is nothing but the crack propagation.
Yes.
Sir, but we have three theories for crack propagation. One is VCCT, J integral, and XFEM. So which
Yes.
particular method will be much more suitable for this?
So it
Because
depends
it is
upon.
nothing but the basically is the energy release rate what we need to find out.
So it is up to us to decide that which out of these three we can use. It is nothing like one is good and other is bad. So it is up to us which one you can use. We have used the first one.
So which one, sir? VCCT. Hello.
Hello.
Hello, sir. Have you adopted VCCT technique or J integral, sir?
The first one, VCCT.
VCCT. Okay,
Yes.
sir. Okay, sir. So may I know the rate of release rate what it was, sir?
Release of load.
Energy release rate, because it is basically a strain energy release rate that will be going to happen as the load goes on increasing.
I am not sure about this moment because we performed this experiment, but those are the things which are available with me in the literature form. So I cannot answer it right now, but I can give you the values. You can write to me on my email IDs.
Okay, sir. Okay, sir. Okay, sir. Thank you very much, sir. Thank you.
So good morning.
Morning.
Sir, I have a doubt.
Please.
When we analyze, we'll get the mode shapes.
Yes, sir.
But when you do the experimental thing, we have to apply the load to the first mode.
Yes, to the first mode.
First mode only we have to apply.
Yes.
But sometimes there will be a participation factor of 90% or above in second or third modes.
Yes, sir.
Then what we have to do, sir?
So that is why we have not taken the mode shape as the way of calculating the damage index, because I know there is a problem in calculating the mode shape of the actual structures. So we took the value of frequency response function as a parameter to check the damage in that building.
Okay, not with respect to the mode shape.
Not with respect to the mode shape, because analytically also, if you find out the mode shape from one software, you will get a different value. If you use the same in the different software, the value will be the different one.
But normally the shape will be same, no, sir. Normally.
Shape, the value, there is a change.
Yeah, there will be change in the value.
Value.
Sir, one more doubt.
Yes, sir.
the damping is changing or reducing when as the damage is more.
Please repeat your question.
The damping value is reducing
Yes, sir.
as the damage is increasing.
Yes.
Right, sir? Any comment on this, sir?
Because time period is increasing. So it
But
is inverse of that. Because when the cracks are there, the building will not excite. It will not vibrate. It will be becoming a rigid one when there is a damage in the building.
okay. So when we were working in Central Power Research Institute, on the shake table we have modeled a similar building.
Yes, yes, it is
When we
possible.
played the earthquake on the building, the damage was at the lower level, that is at the ground floor level,
Yes.
at the beam column junction. But in your case, the damage is at the top floor.
When there was no infill wall. And
No, no.
because in shake, I'll give you the explanation. You can perform this experiment on the shake table, which is a very good method of doing it. But in the lab where we have casted and tested, we were not having that type of facility over there. So we have given the load at the top floor to induce the damage.
That is the impact load you are giving.
We have given a load, not impact. Impact load is given by the impact hammer to give the excitation. But load we have given through the hydraulic jack, and that too at the top floor. So when you are giving the load only at the top floor, the failure is going to be there in that floor only. So that is why it is not going to give you the exact picture which you are getting on the shake table, because shake table load given is totally different one, because it simulates the earthquake.
Yes, sir. Yes, sir. Thank you, sir.
Thank you.
Hello.
Please say.
Hello. Yes, good morning, sir.
Morning.
Yeah, my question is, you talked about sensors, that we can embed sensors in the new structures to detect the damages.
Yes, yes.
So in that case, how do you know if that sensor is working? If the system goes wrong in the middle, then what is the solution for that?
See, we have different kind of sensors. We have the wired sensor, we have the wireless sensor. Those sensors are ultimately going to give the value in your PC. So now we have a technique like we are putting a pacemaker in the heart, and that pacemaker reading again we are taking as a, if we simulate that thing with our human being. So it is also the same concept, because that is going to give you an idea, means how your heart behaved in that full 1 year of lifespan of that. And then again you are going to a heart surgeon, he will test it and he will see the record of those 1 year. Similarly is the sensor one. Sensors are connected with the data acquisition system. If they are giving that value, sensor number 1, data acquisition system is taking the value. If the value is coming to be correct one, so we will say it is working properly. If there is a change in value, we can say that maybe that portion where the sensor is located, there is a damage in that.
So generally, what is the lifetime of those kind of embedded sensors?
So they are being used nowadays, means in the 20th century only we started using those. So till now, so they are working very good. Maybe after 50 years, what will be their life? We cannot predict, but as per the manufacturer, they say it has a life till the building is there.
Okay, okay, thank you, sir.
Thank you.
Good morning, sir.
Morning.
Sir, I would like to know that the damage index what you have provided, that it is greater in the third floor, consisting of infill walls, but it is very much less than in ground floor. So what is the action of these infill walls? Whether it is acting as a increasing in the self weight, or it is a beam column action?
It is increasing the self weight also, and it is the beam column action also. And the problem is at the bottom story, when there is nothing which is restraining the movement of the column, so failure was more in those things. But it is just a model which I have casted. I am telling you because this is the thing, because this model casting was to know the earlier behavior of the actual building. Because if you go to actual building, I am not having the 50-year behind data with me. So that data you have to predict. So that is why I have casted that type of building in the lab. But the failure mechanism or the type of failure it has nothing to do with the actual one, because it can change with your experimental setup, it can change with the pattern of the walls, it can change also with the pattern of loading mechanism also.
Yes, sir. One more query.
Yes.
Sir, earlier you have assumed that the flexural rigidity EI, so you have assumed that I is constant, and you have got the results of the damage index.
Yes.
So how can you tell that the I is constant when you're giving a load? That is the dimensions changes, no sir.
No,
So
no, not. It is flexural rigidity means E and I value when we were using it in the software. I is B and D, that is width and depth. So whenever there is a small change, the normally column and beam B and D, it remains the same. Normally, when there is less damage, with the increase in damage, maybe the width or depth may deviate. So I was not having any other mechanism to predict the damage. So the only the good way to predict the damage was to reduce the value of E. Otherwise, in software, it is not possible to reduce the damage.
okay, fine, sir.
Any other doubt? So can we close the session then if there is no doubt? Thank you very much.
Hello, sir. Hello.
Hello.
Sir, can you give the how quantification related to the prediction of the building, sir? Prediction of building life, sir.
Quantification, what do you want?
So how you relate the quantification to the prediction of the building, sir?
See, I told you that we worked on the damage index. If the value of the damage index was from 0 to 0.5, the building there was no damage, as actually you can live safely in those buildings. But from 0.5 to 1, where the damage index was there, we found also in the actual structures that they were severely damaged, and we require either retrofix this the change, or we totally dismantling of those buildings or retrofitting those buildings. So quantification we can just do on the basis of the damage index, that is between 0 no damage to 1 which is totally damaged.
Sir, is it only holds good for the models we have done, or else is it common for all?
I couldn't hear you, please repeat your question again.
Sir, is it only holds good for models what you have done, or is it standard for all, sir? 0.5 to 0?
See, this I calculated in the analytical also, the same behavior was there. I calculated in the model also, the same behavior was there. And when I calculated or when I checked the actual structures, the same behavior was there. So I concluded that yes, this can be adopted throughout, or this can be adopted in actual buildings also.
Well, sir, thank you.
Thank you. Students, from your side, any question? You are there in ME course?
So thank you all the Nodal Center for patience listening. Now we'll have a tea break of 15 minutes and we'll reassemble again at 11:30. Thank you.
और कौन है जो प्रैक्टिकल सॉल्व कर इस चीज के बहुत बिल्कुल सर ये मुझे लगता है हाथ से बुलाना पड़ेगा बेसिकली तो ये सब से फॉल्ट का है इंटरेस्टेड टाइप का नहीं तो वही या फिर कम्युनिटी देखिए कम्युनिटी को तो बुलाया था तो एक बार और ट्राई कर ठीक है तो बड़ा ठीक है टी ब्रेक हो गया ये एक प्रोफिट मिला यहाँ टी ब्रेक हो सीधा कंटिन्यू तो नहीं है हाँ अलग का बना और ये नहीं करना चाहते तो इसमें पैसे ले लो मैडम आपको पैसे विकास 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 ट्रेनिंग चल रही है ट्रेनिंग चल रही है इसको तो नीचे फोकस कर रहे हैं तो आप जी में आ रहे हैं स्माइल उसका नाम करना है
कितने जुड़े हुए सेंटर्स हैं? हाँ जी, कितने सेंटर्स हैं अभी? कौन सा?
अभी ये फोल्डर की कॉपी कर लो आप, डेस्कटॉप में होगा बारी बारी वही।
ये कहाँ बनाया हुआ फोल्डर? अपना फोल्डर बनाया कोई? अच्छा, चलो फिर इन्हीं में उसका भी कर देंगे दूसरा। अब उनका कहाँ है? कौन सा? इस साइड में?
नहीं सर, इधर है। इससे भी इधर।
ये वाला? इसको भी अंदर ही डाल देता हूँ मैं ना। अरे
स्टूडेंट लोग नहीं आ रहे हैं?
आ रहे हैं।
सर जो संजय सर, वरिंदर सर अभी आए थे, उनकी आईडी आप कॉन्टैक्ट नंबर सेंड कर दीजिए।
उनकी?
हेलो।
उनका है, ये अपने स्टूडेंट्स कहाँ चले गए? Welcome back after this tea session. For now, we have with us Colonel Harry Sidhu, who is retired additional chief engineer from MES. He has done his MTech structures from IIT Mumbai, and he's a member of many life member of many organizations, including Institute of Engineers, and independent consultant on particularly on repair, rehabilitation, waterproofing, and has got a vast experience in the area of waterproofing and repair rehabilitation, and has handled many prestigious projects in this part of country, including your waterproofing of international Indira Gandhi Airport at New Delhi, then many projects of Nestle and other multinational companies. He is a regular faculty to this institute, visiting faculty to this institute, and has contributed in many of our programs. particularly when we are conducting any program on repair, rehabilitation, waterproofing, concrete protection, and in such areas. So I welcome you, sir, for this session on. We will be having actually a regular interaction with him throughout all days. There is a one from starting from today. He will be interacting with you one session per day, and will be sharing his experiences with you. And I hope that you will really get benefited from his experience, and it will be a good learning experience for all of us. So I welcome you and hand over to him for his session. Thank you.
Thank you, Dr. Sharma, and good morning to you, ladies and gentlemen. Before I get on to the topic proper, I shall be giving you a brief introduction about what myself and my activities are. I'm the visiting faculty to this institute for MTech and Construction Management, external examiner for MTech and ME students, IIT Mumbai and TIT Patiala, consultant for structural design, rehabilitation and waterproofing. As far as design is concerned, there is hardly any structure of other than bridges which I have not dealt with. Naval jetties, aircraft hangars, multi-storied buildings, and whatever you may say. And I have developed my own inferences from those things as lessons learned, and that is what I'm going to share with you today. I've been writing expert columns in Hindustan Times. I've been a consultant to Chandigarh Administration and Punjab Agro-Industrial Corporation on waterproofing, and presently I'm the Director Technical to Buildcare Services Private Limited, India. Now coming to the subject proper, design and economic considerations. I shall be talking to you not about how design is actually done, because that is a very extended and a vast topic. I shall be talking to you about the certain basic essential issues that you must keep in mind while dealing with design. What do we understand from economy as related to design? It's a very important question for you all to answer to yourself. Does it mean making a cheap structure? Certainly not. What it means is the structure must fulfill the intended purpose. For whatever purpose you are building a structure, it must fulfill that, and it must fulfill the life expectancy for how long you want to build a structure, whether it's going to be a temporary structure or it's going to be a permanent structure. And that must be done at the minimal cost. This is what we understand from economy in design. Design concepts. When we talk of design, people normally refer to architectural design. Architectural design is only line and form, whereas the second thing is the structural design, that is the strength, the muscle and the bones to the structure. I shall be talking about the structural design part of it. I shall be covering this topic into a couple of stages. Structural design, then there are some common aspects to structural design, and in that I'll be dealing separately with the masonry structures and separately with RCC structures, because those two things are poles apart. Now when I'm dealing with design, I'm certainly not wanting to deal with the structural designer's mistakes. I'm going to deal with the structural designer's oversights. Certain things he ignores, but certainly not the mistakes, because the mistakes, if there are, they can be disastrous. And we see disasters taking place every now and then. The newspaper is full. The TV, television telecasts are full. They are all structural designs. I'm going to not deal with the mistakes of the structural designer. Now coming to the design process. It is not a mundane mathematical process. What we have today come down to is take the input data, feed into the computer, and get the output. You have a CAD interface and you get the drawings. You don't even know what you have done. That is not the purpose of design. It is an art. Ladies and gentlemen, it is a very, very important thing that you have got to understand. What does the artist do? When you go to an artist to get your portrait made, there is a difference between going to a photographer to get a snapshot and going to an artist to get your portrait made. The artist first looks at you, forms a mental picture about you, and then starts drawing after he's put you in that particular pose which he thinks is going to suit you. That precisely, ladies and gentlemen, has got to be the approach of the structural designer. Now, what are the ingredients of design? The ingredients of design are first and the foremost is the service requirement. The service requirement is the most important thing. You must know what is expected out of my structure. Is it going to be a hospital building? Is it going to be a cinema hall? Is it going to be a classroom? Is it going to be a residential building? And so on and so forth. There are n number of things to which a structure can be put to. So first you must know the service requirement. Configuration. This is a combination of your structural knowledge and the architect's impression about what he wants to do. The very important thing, you want the structure to be a load-bearing structure. You want it to be a partially load-bearing structure. You want to be a structural framework, space frame, and what all you may say. So you got to first understand what is the configuration that you are wanting to make. Then the response. What is the kind of response that you expect from the structure? There's a lot of importance to this. You're making a building. Can you expect or accept violent vibrations? Can you expect or accept failure under certain conditions? For example, a hospital building must withstand the most severest of the earthquake effects, whereas a normal storage accommodation does not have to meet that kind of a stringent requirement. So you got to understand what is the kind of response that you expect out of your structure. Then conceptualization. Based on these three things that you have gone through, you conceptualize, like the artist makes a mental image about the object, you also try to make a conceptualized image in your mind. This is all happening before you've drawn a single line on the drawing sheet or made a single entry on your calculation sheet. You try to conceptualize that this is what is going to look like so that you have a virtual image of that structure in your mind. Thereafter you come to the interface with the architect, the most important thing and the one thing that is lacking and missing everywhere. What I want to explain from this point is the architect has made the drawings, his team has made the drawings and sent it across to the structural people. The structural people straight away start drawing lines of this is where the beam is going to come, this is where the column is going to come, and so on and so forth, everything. And the calculation process starts and you go to the computer, feed in your data and get the printout of the drawing. That is not the way to deal with structure. You must try and understand as to how the various components are going to behave. Therein your experience will count. Therein your learning will count. Therein your guidance by the people who have taught you will count. For example, there is a case of somebody presented a case of a cantilever portrait, entrance porch. The architect wanted a thing to be supported from the beam itself and not extending the canopy towards the columns. He says, I want to give the floating effect. I put my foot down. I said, sorry. Do you understand the implication of this? There is a beam between the columns and there is a porch cantilever coming out. It is not extending toward the columns. The entire load is going to be transferred to this beam as a torsional load. Imagine designing a beam for torsional effect. So you have an interface with the architect and try to make the other person understand, and most probably he will suit your answer. But that is possible only if you know what you are doing. Now, thereafter, coming to the first lesson, that is, as a designer, what must you do? For those of you who were present here yesterday and those who happened to listen to me, I made a passing reference to this concept. We must be able to first draw the deflected shape of the structure under given load or combination. That is what my learned colleague said, free body diagram. You must know where tension is going to develop and where compression is going to develop. Where there is going to be pure tension and where there is going to be pure compression and where there is going to be flexural this thing. You may not know the values, but you must know that this is how it's going to sway, and at the junctions, how is it going to behave. This is very important for you to understand, because at the end of the day, when you get the results, and when you put the reinforcement at the various places, you should know if you've not gone wrong. He's citing a personal experience. After the analysis, our computer program did not have an interface with the CAD. So we had to physically take the analysis result. At one point, we found that the displacement at a particular node was working out to be more than 1 meter. Now that raised alarm bells in the mind. How can a particular place deflect by more than 1 meter? So you start checking back. So unless you get to have that kind of a understanding, you will go grossly wrong. Now common aspects, coming down now to the subject proper, the common aspects which are common to RCC as well as masonry structures are as follows. The soil investigation. Very commonly it is said there is built up area already there, and this building has been based on this safe bearing capacity, so you need not do soil investigation. Sorry ladies and gentlemen, that is a wrong premise, because today particularly when the land is becoming more and more restricted, you do not know which were the landfill areas. Even in a recent town like Chandigarh, you have certain areas which were identified for dumping grounds, where all the surplus muck and malba and waste material is dumped. After years, grass will grow over it and it will get covered with vegetation, and when you are going to come and build another building over there, you will not know the history of that plot. And that may be an isolated place. So please, for heaven's sake, do not ignore this important aspect. Joints. I shall be covering this aspect in a special separate session, but it must be understood that joints are provided as an essential part of the structure. Why? I shall be dealing separately, but you must understand where a joint is provided, its location, as well as how are you going to seal it. Joint means creating a separation in the building right through and through. You can't leave it open to sky. You can't leave it open to atmosphere. You must know what is the size of the joint, how much that joint should be provided, and how is it going to be sealed. That is a separate topic by itself. Probably I will be taking it tomorrow. Unambiguous detailing. This is something which is lacking very badly, particularly in the case of automated design processes and being handled by beginners. They say standard engineering practice. Everybody knows. I want so many bars to be provided on top, so many bars to be provided at the bottom. This is the diameter, this is the spacing. So it is a standard thing. I don't have to write down everything. Sorry. There is nothing which is called standard engineering practice. Please tell me a book where there is a chapter on standard engineering practice. It is a misnomer. You must define categorically as to how you want to provide the reinforcement. Physically see on a piece of paper to see whether 10 bars of 20 mm are going to be fitted into that place and still have place for reinforcement and concrete to go inside. I shall show you some photographs. You will understand this implication a little more. Compatibility of materials. When you are using different materials in different places, particularly for jointing, for two members joining together, you must understand that they have got to be compatible to each other. Compatible means they should not be different in their elastic and thermal behavior. They should respond similarly under a set of thermal and elastic considerations. Then false economies. This is something you got to guard against. There is no economy which says reduce this to this size because I don't have the money. Sorry. If you don't have the money, don't build it. But if you have to build it, please make sure that the required stipulations are met with. Now coming down to masonry structures, the basic aspects are the slenderness ratio, a thing that we have learnt very early stages of our engineering studies. But tell me how many of you have utilized it when you are dealing with a masonry structure? Without realizing it is the most important aspect as far as masonry structures. I shall define it a little more in detail. Openings. Nobody considers. Today people want large open windows, highly glazed openings, and still think that masonry structures can do it. Sorry. Openings have a very important bearing on a masonry structure. I shall again explain it in detail a little later. Design wall thickness. Again, you must understand that every time I'm stressing on certain issues, all these issues are very often ignored, left to the lay mason on the ground to follow. Wall thickness. There is hardly anybody who ever designs the wall thickness. There are standard thumb rules. Single story building, 9 inches wall. Double story building, maybe 9 inches, maybe 1.5 brick wall. More than that, they've got thumb rules. Internal walls this much, external walls this much. Sorry. There are standard methods of designing, and I'll show you with the help of certain nomograms, simple nomograms, to understand that these are not really correct. Bearing stresses, very important insofar as your beams and lintels resting on the adjacent wall are concerned. We provide standard bearing blocks without realizing what is the actual bearing stress that is working out. It's not difficult to do it, but we don't have the patience to do it. Now coming down to the slenderness ratios, I shall just show it. I'm not defining it because this is a very elementary thing for you all to understand. It is the ratio of the length to the effective least effective dimension. It is different for columns and different for walls. You can read it at your own pace. There are more important things to discuss, so I'll skip over this. Now this is a sketch I want you to understand in totality. You have the pointer option. The pointer option. I'm doing it with the pointer. Huh? I'm doing it with the mouse. The pointer is not showing up. Anyway, you have the wall thickness TW, and you have the adjacent section in which there is an opening, and that opening, if the buttress is not less than h by 6, that is the height of the wall divided by 6, if the size of the supporting cross wall is not less than that, and the free end. In the first case, the effective length is 1. And in the second case, the effective length is 0.8 of the length. Understood? The effective length, you see, slenderness ratio is effective length divided by the width. So the effective length is getting disturbed with the opening and the size of the cross wall, right? And on the free end, it becomes 1.5 times the effective length, right? So that is a major difference to start with. Then you have the effective length based on the size of the opening. Effective length is 1.5 L2A, depending upon what is the size of the opening. Now, I don't know, you got to help me out with the mouse because otherwise I'll not be able to explain.
This one.
Previous. Okay. Thank you. So, as there is a handbook called the Handbook on Masonry Design and Construction, SP20, as you see here. This is a standard publication from the BIS. It has undergone a lot of changes, but the changes have made it a little more complex as far as the design of the wall thicknesses is concerned. Herein, I am taking the older version, which is now obsolete, but aim of using this nomogram is only to display the interaction and the interrelationship between the various components. You have the vertical axis on the left as the basic stress. The basic stress is laid down in the building code as based on the strength of the brick and the strength of the mortar, mix of the mortar. So based on that, that is the starting point. You have the basic strength, basic stress. Then the next vertical line is giving you the story height, 1 to 4, because beyond 4 stories, you don't have a masonry structure. So that is giving up to 1 to 4. Then you have the first reference line A. Thereafter, you have a span point. This is all arbitrary. Made the nomogram. This is, don't ask me why this is, but this is just working the conversion of the formulas into this kind of a understanding. Then you have the reference line 2, and then you have the next vertical line giving the percentage openings. From 0, that means no opening wall, up to 50%. Thereafter, you have the span points. What is the span across which you are considering? That is 3.0, 3.6 and 4.2. Now this was changed to a more rigorous analysis because the BIS people found that these limitations were very strong generalization of the whole thing, because the spans could be more different from what are being given. This is just one of the nomograms. There are at least 20 nomograms given in that handbook. And because the various other parameters were there, so they discarded these nomograms, but these nomograms are still very handy for you to understand the importance of each thing. Say, for example, for a basic stress of 9.5 kg per centimeter square for a double-story building, you take this line here and take it to the point A, the first reference line, and then you draw it down through this span point and come to the point B. Straight line relationship. This is just a set square doing the job. Thereafter, you have the percentage openings, assuming that you have the 40% openings here. Then you can see that for this set of combination, for a span of 3 meters, you need to have a 1.5 brick wall for a span of 3 meters. And for 3.6, it is still probably 1.5, but then when it goes to span of 4.2 meters, the same thing becomes 2 brick wall. You understand the difference? This is just trying to show you the interrelationship. Please don't quote this as a standard method of working. This is only to make you understand as to what is the interrelationship. Today this is not valid, but the relationship is certainly valid, right? Now, this kind of cracks on a very small, you can see this opening is very, very small. And even in this opening, you have this kind of cracks that are going up. Why? Because we have not tried to bother about the simple principles of masonry design. These are a little more clearly explained by the bed blocks are inadequate sized, so the bearing stress has exceeded and the cracks have occurred in the wall. Similarly, at the openings, at the bottom, you have the cracks developing because on the left and right of the opening, the load is there, and in the middle portion, the load is very little. So, differential loading is certainly going to lead to cracking. Now, suggested reading, you please refer to these two publications in great detail, and if you can afford, please buy them from your personal finances so long as you are students, because BIS gives a very heavy discount for the students. What I have shown you is only a bird's eye view of the whole thing. I obviously cannot give you everything, but Handbook on the Causes and Prevention of Cracks, SP 25, is a gem. It is an exhaustive handling of all possible kinds of situations in a building that you must look after. If you have noted down, shall I go ahead? Now coming down to the RCC structures. This is totally different from what we have done before, other than the common this thing. Here are the other important aspects. RCC is a very strong thing, but only strong in case we understand it. Otherwise, It is the reason for most of your failures. Basic aspects on RCC are the idealization. Now comes the idealization as to how you want to idealize that structure. Then you have the boundary conditions. I wonder whether you all know what are boundary conditions. Boundary conditions are the support conditions, the end conditions. Something like, the simply supported, the partially fixed beams, the hinged beams, fixed beams, partially fixed, partially hinged, and so on and so forth. Those are the boundary conditions. So you must exactly know the boundary conditions as to how they are going to be there on the ground. I'll tell you how the boundary conditions, it is not by your wanting to do something, but how it is going to be followed on the ground and how is it going to be detailed is more important than your thinking. Then you have the specifications for concrete. Very important, because the whole thing revolves around the M grade and what you're going to provide on the ground. Detailing, I've already mentioned that you must know exactly how the bar is going to start and where it is going to be bent and where it is going to be terminated. Then the deflection. The limit state of design is very clear on the various limit states, and deflection is one of the important ones. Crack widths. Shall come to the crack width size a little later. Inverted beams. Inverted beams have become the order of the day because our architect friends, they want a clean soffit, and in that clean soffit wanting, they take the beams upwards. With the result, you are making the design uneconomical because the T-beam behavior is lost. The architect is probably not concerned because it is the owner who is going to pay. And everybody else is interested because everybody's cost and takeoffs are linked with the what? The cost of construction. Everybody gets based on the percentage of the cost of construction. And then you have problems of drainage. We shall have a sketch on that subsequently. Long corridors. Those of you who were present yesterday, I made a mention of this. I'll explain it in a little more detail when the slide comes. The thermal response, particularly up north, where the temperature varies from 0 degrees during winters to excess of 50 degrees surface temperature. I'm not talking of the atmospheric temperature. The surface temperature, excess of 50 degrees. So that 50 degrees diurnal variation in temperature is going to have a vast amount of effect on your structure, expansion and contraction. Now, another important lesson to learn is structural behaves the way it is detailed and not the way it is idealized. You say, I've made a simply supported beam, I've made a fixed end, but the detailing on the ground you have not specified. It doesn't understand the structure, it doesn't have a mind to understand the designer's concept. The structure will behave the way it is detailed. Very important. I'll give you an example of this with the help of a sketch. Now, anybody, what is the underlying principle of RCC? RCC is RCC because of what principle, what effect that you observe. I mentioned that point a little earlier, but I said I'll talk of this a little later. Not to spend more time on this, it is the theory of cracking. Because unless concrete cracks, it will not transfer load to the reinforcement inside. Concrete is very strong in compression, but very weak in flexure and tension. So to utilize the strength of the steel inside, the crack has to occur. So don't get alarmed that this beam has cracked. Get alarmed if it is cracked beyond the acceptable limit. Right? So you must understand that why the crack width is important. You see, this is a poor slide taken with the help of a mobile camera a long time ago. The upturned fascias on top of the building, their junction with the slab are often cracked. A very simple thing to overcome, but we don't provide any attention to this. And then people come back and ask, sir, what shall we do to cover up this? To understand this aspect, we have a wall, a slab here, another wall, and the roof slab with the first thing that the potential crack lines are shown. Right? You understand that these are the places where the cracks are going to occur. What is the answer? Answer, ladies and gentlemen, is very, very simple. To overcome our phobia for appearance, provide joints, provide separation at the places. Why does the crack appear and appear unsightly? Because it is irregular. But if in the same irregular lines, if you had a defined straight line, that crack would not appear bad. You agree with me on that? So, the answer, ladies and gentlemen, is very simple. You provide clear-cut separation. And separate it out. You may have, if you still want, I want to have a brick-faced wall all through, if you're so very keen, you can have artificially laid bricks on top of it. But there should be a clear-cut gap over there. Because a natural phenomenon, the vertical wall, the RCC is, sorry, the brick wall is a vertical member. The RCC is standing on top of it. The behavior of this RCC is like this. The behavior of the brick is going to be vertical. There is bound to be a crack at that junction. You cannot avoid that movement. Whether you see it or you don't see it, but the structure moves. And that crack is bound to occur. So you've got to look after that aspect and provide a joint over there. That is one of the simplest form of joint providing. Now talking of the boundary conditions, I made a simplified member wherein you have the foundation, you have the column, and you have the beam on top. It depends where are you terminating your reinforcement on top. That will identify whether it is going to be a simply supported member or a fixed member. You understand? If you are taking the reinforcement of the column to the development length into the beam and vice versa, it is going to be a fixed. And in case your reinforcement is adequate to overcome to resist that bending moments over there, only then you can say that it is a fixed end. In case you have provided reinforcement less than that, then it is partially fixed. And please remember that a simply supported condition, WL square by 8, exists in the case of RCC only in the textbooks. On ground, that situation does not occur, because you cannot have in a building member a wedge and on top of that a beam. There is going to be certain amount of fixity of a smallest lintel to the largest beam at the junction. So that kind of a thing you got to understand, whether it is going to be simply supported and it is going to be fixed, and accordingly you got to use that formulation in design. The range between WL square by 8 and WL square by 12, you got to understand that where does your structure lie. It's a very big range. Then you're coming down to the stiffness, you're coming down to the foundation. Have you heard of a hinged connection in the case of a RCC structure? Most of you will say no. But there are situations where you are forced to provide a hinge. Even in the case of RCC, I have done that at a very early stage of my learning. What is the property of the hinge? It has zero moment. So where you cannot accommodate the moment part because of constraints of size, because the moment you have moment at a junction, you have the stresses, particularly in the case of foundations, portal structures, bending outwards, the bearing capacity of the soil is poor. You cannot provide that toe because of the restrictions in the space. So you have to perforce go in for a hinged connection. So how you take about that connection, whether you take it, that aim is only to either take this side bars this side and this side bars on the other side. Point understood? Then you come to the stiffness. Stiffness is what? I divided by L, moment of inertia divided by the effective length. Very often we are coming across in the case of undulating crowds. These are site problems. You get this feedback from the site. You have one side of the building which is sloping down, and instead of providing heavy amount of filling under the floor, the executive on the ground says, sir, I'll provide that plinth beam a little higher, so that, and you design the slab as a inverted slab on top of, floating slab on top of the structure, because columns you already got to provide beam. A lay designer will say, okay, go ahead. What are you doing? You're doing nothing. He just designed the slab to be supported. But what is happening? The effective length has got changed. Changed by the level, the difference. So I divided by L, I remaining the same, L getting reduced, the stiffness will increase. With the increased stiffness, you'll attract more moment. You have not redesigned your column because that column is already constructed partially. So please understand, these are small things, but they have got implications. So this is important from the boundary conditions point of view. It is just not that what you have planned, I'm planning this thing, the structure will not listen to your planning. This is just showing you poor specifications for concrete. Congestion of reinforcement. For my outstation participants, you will not understand, but for my local audience over here, these photographs that I'm showing in the next 2-3 slides are from a building in this particular block itself. Right? You will recognize this, but unfortunately they have already been painted. You will not be able to see what I'm trying to show you. These are the columns, the administrative block columns, and these are the beams which are coming and resting over here. And you will find that there are covered up patches all over. Patchwork to conceal honeycombs. If it was only in one place, one could understand. But if the same process is repeated over the entire column, then it is not a workmanship defect. There is something common to it, and that is congestion of the reinforcement, because heavy sized beams and heavy sized columns, the reinforcement is not allowing the concrete to go inside. So this is what I said, importance of detailing is very, very important. I hope you can see what I'm trying to show. Now the deflection part. The deflection is not an immaterial thing. In the case of large sized openings, you will find column to column there is a beam running across, and you got a steel glazing inside. You give the measurement as per the opening, and when you come and try to fit that thing into the opening, your frame does not fit it. Why? Because the center portion has already reflected and come down. It may not be visible to you, but when you take that frame, so then you start chipping it off. In case you have provided this thing without doing it earlier, then your glass will crack when as the load increases, because the glass is fragile. So what is the answer? Answer is to take the deflection into consideration. Talking of the crack widths. Crack widths are important. I'm trying to show, there are limitations of the sketching because of my PowerPoint working. They are not on AutoCAD or any specialized structure software. So, pardon me for the inaccuracies of drawing. You have a crack width on this side which is large. What I'm trying to show is that it is going beyond the reinforcement. It is cutting the cover and going beyond the cover into the past the reinforcement. The one on the left is a crack which is staying below the reinforcement. The one on the left is something which is acceptable. The one on the right, it is not acceptable. So, one of the most important thing is it should not be visible to your naked eye. And the second thing is that when you're providing a coating on top of it, the paint or whatever you're trying to do, it should be having that much of elasticity to cover that kind of a crack, so that aesthetically it is not a bad thing, right? Point understood? Inverted beams. I've already mentioned inverted beams lose the action because of the T-beam behavior, so the design becomes costly. They cause problems in the waterproofing and the terrace drainage. Potential crack tension zones will lead to leakage and the corrosion of reinforcement. because the tension zone will be exposed to the sky. The inverted beam, it will have a crack at the top and the rainwater will keep affecting it, and the tension zone reinforcement will get corroded earlier than the rest of the structure. So the choice is yours. How do you drain out water? On the ground, people don't appreciate this, and very often you find people providing pipes running across this after constructing, and then they realize where the water will go. They chisel out holes, damaging your beam, and in turn the rest of the structure to put a pipe, and that pipe size is often inadequate, which will get blocked with even a flying leaf which goes and lands in front of the opening, and then you have that whole water is ponded on top of the roof and you have the problem. Now, crack in the one-way slabs. This was something which I mentioned yesterday. You have this kind of a long corridors. You go to any educational institution, you go to any office, you will have a corridor running through the building, offices and rooms on either side. If you have ever tried to bother, today you may not be noticing such a thing because most of the accommodation has become air conditioned and you started having false ceiling to cover that. But many of the structures, the passages are still not covered with false ceiling. If you happen to look up, you'll find invariably, that is a guarantee I say, invariably you'll find transverse cracks like this occurring all over, but at regular intervals. The moment you say it is regular, that means there has to be an underlying cause. And this is what I explained yesterday also, and cost of repetition, I'll explain it now. The internal temperature never exceeds an average of about 25 to 35 degrees centigrade. Even in a non-air conditioned building, 35 is the upper limit for the internal temperature. And the external temperature, particularly here in this part of the country, will go to excess of 50 degrees. That temperature differential is acting on the slab, the daytime temperature and the nighttime temperature. There is again a difference of about 10 degrees. So the slab is expanding and contracting. And when we say it's a long corridor, it is obviously designed as a one-way slab. You definitely design the slab as per the span is concerned, but nobody hardly ever designed the transverse reinforcement. Transverse reinforcement is the reinforcement which is supposed to look after the forces in the direction of the cracks. With the result, you just call it temperature reinforcement. And when you say temperature reinforcement, you just go by the code which Jamani yaad kiya hua hai, and then you provide that minimum reinforcement over there and you're very happy. Till such time somebody points out these kind of cracks. So if you design a slab, you multiply by the coefficient of thermal expansion contraction by the spacing by every 1 meter. Keep on doing it. The stress at 2.5 meters exceeds 1 kg per centimeter, which is the permissible tensile stress of concrete. And that is why in the old this thing you say every 8 feet the crack is occurring, or in terms of the metric system every 2.5 meters the crack is occurring. So you've got to either, there are ways how to overcome it. The next question obviously comes, how to overcome it. Either you provide heavier transverse reinforcement, or you provide concealed internal beams in that direction so that the movement is restricted. Right? The choice is yours. I mean, I'm just giving you a hint. I'm not solving any design problem over here, but I'm just showing you the process, giving you a hint as to how this is going. Now coming down to the floors, industrial buildings, storage accommodation, if you have visited any of the old industrial storage accommodation, you'll find the panels are provided anything between half a meter by half a meter to about 1 meter and above by this thing panel. And you'll invariably find that the corners of those panels are cracked. That is a different thing. But the corners of these panels are very often which are cracked. How are those cracked? You have, this is a diagrammatic view I'm showing. These external lines, external walls are the restraining portions. During summers, the floor will expand. When the floor expands, it has to find and get space to go out. But we have not provided any jointing, flexible jointing material. And the floor is trying to go out. When it is not able to go out, it will curl up. You understand? If it is not allowed to go, then what will happen? It will rise up. You probably will not notice it. But with the heavy wheel loads which are going over there, the trolley loads or other things, that thing will crack up like this. In the first stage, ends are curled up, probably cracks are not seen, and in the second stage, because of the trolley loads and other imposed loads which are pretty high in the case of industrial construction, the thing will break down. This is the enlarged view, but what happens on the ground is this is the showing you the principle. Now what is the answer? Answer is very simple, and this is no area of research that I am sharing with you. You must provide panels and you must provide joints. There are various types of joints which are specified and laid down. Expansion joints, contraction joints, dummy joints, and so on and so forth. And those joints should be properly filled up with proper sealing, filling materials. Unfortunately, in India, we know only one sealing material, and that is bitumen. Wherever there is a joint, whether it is on the road or it is on the factory floor, the cheapest thing which is available, you melt bitumen and add a little bit of sand in it, make it into a thick paste and put it over there. That is not a jointing material. It will come out in no time. There are proper sealing materials which are available, polyurethane, polysulfide, and so on and so forth. There are so many of them today. Insert fuses. Ladies and gentlemen, when the doctor performs a surgery, he knows for sure that there are certain amount of fluids which are going to ooze out subsequently. So he puts a drain pipe somewhere and allows that fluid, because he knows that is a natural phenomenon, right? The electrical engineers, they provide a circuit fuse, and every gadget has an internal localized fuse. What is the aim and what is the purpose of that fuse? The aim and purpose of that fuse is that in case of an overload, the whole system should not blow up. The damage should be localized and you can replace that fuse subsequently. We as civil engineers also need to learn from that principle. We are not living in an isolated world. That because this is a fuse is something to be provided by the electrical people, it is not my domain. We must pick up that hint and try to provide a fuse. Now, what is the purpose of the fuse by definition? Very simple. That should be the localized place of failure. For you to allow you to come back when the conditions are all right to repair it. But can you think of a situation where we can provide a fuse in the case of our civil engineering? Anybody guesses? Anyway, let's not, because there are people on the network. There are dummy fuses. Dummy fuses that where a crack is going to be there, as I mentioned, slab and wall construction is one. Panel walls, column and infill panels, where you know the cracks are going to occur. You provide a dummy fuse over there. What is that? You're filling up that, you're providing a joint, you're providing a gap over there and filling it up with an elastic material, flexible material, so that covers the inside crack and does not appear unsightly. Those are called the dummy fuses. And then you have the structural fuse. Structural fuse is a concept I would like to share with you and try to tell you, you should use it whenever you get an opportunity. Multi-storied buildings, you find invariably, as you go to the upper floors, there is beam and the infill wall, there is invariably a crack at that junction. And then at the side. So those are the places where you need to have when the deflected shape is there, you need to provide a groove over there and fill up that thing with elastic sealants. Whereas now coming down to the structural, this thing, a very important phenomenon, you know, a beam. What do you want in the case of an earthquake? If you've gone through those 23 or 21 tips of the IIT Kanpur, which have worked up on the earthquake resistant structures, they want, what do you suppose, supposing we are sitting and working over here, earthquake strikes, what is our emphasis? Emphasis is the roof should not fall on my head. We know damage is going to occur. Earthquake is something too devastating a thing. You cannot say that this paneling should not fall down. Your major concern is what? Your beam and your slab should not fall on your head. You got a very important issue over here, that every beam has a point of contraflexure. You're aware of that? Point of contraflexure is a place where there is no moment. But at the same time, if there is no moment, the shear forces are maximum. So if you are going to able to provide heavy shear resistance at those points of contraflexure, the damage will take place, but it will not fall down. So this is exactly what has been done at the point of contraflexure. I have not shown the main reinforcement in this. I have only tried to show the extra reinforcement from the sides crossing, providing a hinge now here, so that that place where I've shown you the severe earthquake cracks, at that place, because we are crossing, we are providing that reinforcement, shear reinforcement gets added. But its moment of resistance is zero because you have provided it on the neutral axis. The reinforcement is at the neutral axis. This point registered. So, when the earthquake will occur, there will be heavy shaking. There will be cracks at that place, yes, but the beam will not fall down. When the earthquake is over, you get over there, prop it up and repair it. There are plenty of repair techniques available today to us. Now, provision for maintenance. We come across situations where the structures have been provided with no place as to how to maintain, particularly going to the roof. There are many times in which, when if you got to go to the roof, there is no way to go to the roof because they say roof is supposed to be inaccessible. It's not meant to be used. But then, ladies and gentlemen, you've got your water tanks on top, you got your waterproofing on top, you got your air conditioning systems on top, and so on and so forth, and everybody does not come with a ladder to go on top. You've got to have some ways to go up. I shall share with you sanitary shafts and plumbing, access for maintenance, upturned box-shaped fascias. I'll give you photographs of each of these. Access for periodical services. Upturned fascias. Fascias are by and large losing popularity, but then there are people who want to provide us clean soffit and the fascia is turned up. And they just provide a pipe, small little pipe for the water to be drained out. That pipe gets blocked in the very first season. And this is acting as a place for storage of water. Water is just standing over there. So please, if you are going to provide an upturned fascia, provide it by all means, but provide a proper opening and not a pipe. If you got a plumbing stack, which you are supposed to have, because no architect will like those pipes to be visible on the elevation. But he is not concerned with finding out what is the size of that stack that should be there. I have for myself visited certain buildings here in Chandigarh, a modern city, where if you had to go up, you had to, including the PGI, if you had to go up into the stack, you had to go through an opening in the floor level, the toilet. You go to a toilet, you open a window, and from there you can see the stack, and you can only see it, what is visible in front of you. You can't go up and down. Please realize the poor plumber is also a human being. When he goes up, he's going to go up with some tools. He's going to go up with a bag, some spare parts, some pipe, some fixture to go up and down. Invariably, that is not available to be provided. If nothing else, at least provide rung ladders for the poor chap to go up. Very simple thing, it occupies no space and hardly any cost. But that thought, उस गरीब आदमी के ऊपर भी दया आनी चाहिए, ठीक है? Certainly maintenance has to be done, but you can definitely reduce it. Now there is another thing. Today, there is a lot of emphasis on strong cement. There is a fat, bald actor who acts on this thing. Sasta nahi, tagda. Nonsense. They're making a fool of us. And we are becoming fools. What is Virat Shakti and what is the Buland Shakti? These advertisements should be banned. They are making fool of this thing. He says, Jang Virodhak cement. I can understand red oxide being used as a primer on steel. But I have never been able to visualize that same poor red oxide being added to the cement will product rusting of cement, of reinforcement. बेवकूफ बना रहे. I'll show you another slide, which I got that advertisement withdrawn. There is an organization, self-control organization of this thing, ASCI. I say, why do you, somebody has a big iron ball and he is hitting that wall with that. Is it ever happening on the ground? I tried to, at one point of time, I tried to cover my veranda. Because of lack of space, the contractor said, sir, I'll book a 4.5 inches wall over here. I said, external wall, 4.5 inches? He said, then what? I said, somebody can break it easily. I said, sir, you tell me out of so many years of your experience, you have seen people breaking windows. But have you come across a person who says that theft took place because he broke the wall and went inside? Very right. Has any one of you heard of a situation like that? So why do you require, now coming down to basic brass tacks, try and understand, ladies and gentlemen, across the world, across the nation, please listen. Our brick strength is at the best 70 kg per centimeter square. And that also is difficult to get. Why do you require 53 grade cement? Our bulk of our concrete construction is M220. Why do we require 53 grade cement? If that puts that message across, but then you go and, you see, I belong to an era when we were working on 33 grade cement. Why we have migrated from 33 to 53? Very simple. When 33 grade cement was being used, there were hardly any cracks in the buildings. And ever since 53 grade has come, that Virat Shakti and Buland Shakti has hit the market. There is no building which has got no cracks. Reason? Is there any special vitamin which is added to make it 53 grade cement? Ladies and gentlemen, the raw materials can vary from one location to the other. But nobody is adding any vitamin B complex or vitamin D3 as it is becoming more popular today. It is only what is the difference between these three. It is just the fineness. You're grinding it more fine because the industry needs 53. Because of the special type of structures which need high strength. For that 53 grade cement is being used. But because the factories have upgraded themselves to 53 requirement, they cannot downgrade themselves and sell because their ball mills are programmed for 53 grade size. So 43 grade cement is now today available as a matter of request at a premium. You can't help it. But then heat of hydration is increasing. You've got to lay more and more emphasis on curing and timely curing. This is the advertisement I got it withdrawn. People from Punjab will understand and appreciate this. What are these things? Bina swah wala cement. What I have circled out for those of my friends who cannot understand and read. Bina swah. In Punjab, swah is referred to ash from the chula. What is intended to be conveyed is fly ash. The intention of saying that this is Portland cement without fly ash, what it is being conveying. Swah means chule ki rakh, conveying a wrong impression to the gullible viewers. I have the honor of getting this advertisement withdrawn, but how many advertisements can I fight for? But we've got to educate the people around us. A word of caution, an over-reinforced section is dangerous. I don't have to amplify this. This is a commonly understood thing. To conclude, observe. Have an observant eye. Analyze. Whatever you observe, try to analyze why this is so. If you cannot find the answers, consult somebody. Somebody will be knowing. Solve. Try to solve the problem. Try to develop that kind of a nature. Give civil engineering its due. Ladies and gentlemen, I feel myself to be a very proud person because I'm a civil engineer. But ask yourself a very simple question, that if you are standing on a site, what is the contribution that you are making to that site? By your presence or by your absence? The work is going on just as good or as bad as the workman who is actually working there. Have you gone to a mixer operator and asked him whether he is doing something correctly or wrong? You can ask him only in case you know what is right. You are just watching like a dummy. Ladies and gentlemen, these are small little things. I have spoken for nearly about 2 hours to you all. Have I spoken of anything which involves research? Anything which requires a lot of calculation? I have just shared with you some common observations, but each of these observations, please tell me, how many of you were aware of the importance of these observations? We've gone to the moon, we've gone to the Mars, but we do not know how to solve simple civil engineering problems. My request to you all is, please give civil engineering its due. It's long overdue. Beware of false economies. I'll not spend more time on this. Learn. Learning should be the bottom line. Your aim anywhere. Try to learn. Learning from the point of registering and not only scoring marks. I mentioned yesterday that I got 2 points out of 50. Those 2 points out of 50 have transformed themselves into me, and I've started learning. It has paid dividends. Tell me how many important people in the world were high scholars. You got to understand the implication of what you're doing and try to learn each day of your life. Thank you. If you have any questions, I'm sorry I've already touched 1 o'clock, but then I had to cover the entire topic. If you have any questions, I'll be more than glad to answer them. First, starting from my friends here. No questions outside?
ಹಲೋ ಆಯ್ತಾ ಬರ್ತಾ ಇಲ್ಲರಿ ಹಲೋ ಹಲೋ ಹೌದು ಆಲೋಚನೆ ಮಾಡ್ಕೊಳ್ಳಿ
Yes, please put your question across.
ಹಲೋ
Yes, please speak.
So this is from Jain Engineering College, Belgaum, sir. Can you hear me?
Yes, you are audible.
I'll
Continue with your question. Sir, reply कर दीजिए आप आगे से सुनाई नहीं देता.
I have not understood. I can only say understand help. You are audible, but your voice is getting cut in between.
Yes, sir. Continue with your query.
Question अदा रही बैरल कहता है
Hello, sir. So my question was, you said that we should not use that is nowadays modernly we are using only 53 grade of concrete, but the rate of curing is good in 53 grade concrete and 33 grade concrete compared to 30 grade concrete. So you said that what is the use of using the 33 grade concrete? This cement.
What is the use of
What is the? Somebody who could come close and explain to me what is the question.
Inside a piece of grade cement, we use 53 proper curing.
Sir, your question as to why we are using 53 grade cement, is that so, or am I right?
Yes, sir.
Now the question is, I have no option because only 53 grade cement is available in the market. And I made a passing reference as to why 53 grade is available, because the industry, the bulk consumers, the infrastructures, the flyovers and the big multi-storied buildings, they all need 53 grade cement. So all your cement factories have upgraded themselves to producing 53 grade cement, and they cannot produce 43 in a ball mill. What is the difference? The size of the ball mills is such that it grinds that cement paste to that fineness for 53 grade requirement. It cannot powder it less. They cannot modify that thing every now and then. So people are being misled into the using of, they could probably be, if there is a general understanding and awareness about this, probably some cement factories will start manufacturing lower grade cement, but the industry, the cement industry, there is a big cartel. They will not accept that. To restrict their usage to, if you were asking me, for bulk of my consumption, as far as the normal buildings are concerned, I would still prefer to use 33 grade cement. Does that answer your question? Chalo. Anybody else?
Yes,
Hello.
Yes, please.
I am from Jaipur, sir. In multi-stored building, if some differential settlement is there, one of the columns settles. So what will the next remedy? Means how immediately we can control the situation, because structural defects settlements will be there, and lot of cracks will develop, and building may go in the danger. So what could be best possible remedy immediately after the earthquake, or something happens to one of the column?
Well, there are structural rehabilitation measures. That is a very important aspect of structural rehabilitation. You have to analyze what is the distress. You have to analyze the nature of the distress. You have to analyze the whole thing in relation to the rest of the structure. It is not an individual column which will get affected. Please remember that. The earthquake is not going to affect a particular column. It is going to affect the building as a whole. The particular columns may get disturbed to a larger or a lesser degree. So it is, I cannot give you a generalized this thing. There are methods of rehabilitation which are a specialized topic by itself, and certainly the scope of my present today's lecture does not involve covering that aspect. Otherwise I can speak at length on what your requirement is.
Okay.
Anybody else, please?
Sir, hello.
Yes.
Uh, this is from the Jain Engineering College, Belgaum. So it is not the 43 grade or 53 grade cement, but at the same time the strength matters, sir. What we have observed is in the case of the 53 grade cement, the strength is also to be to the mark. So what that is being mentioned, and at the same time the 53 grade cement wherever it is being used requires more curing. After the proper curing only for so many days, it is going to attain that strength. It is not the brand matters or the grade matters. At the same time, it is the strength matters according to the practical observations. Thank you.
You're talking of the strength part of the structure, is that right? Yes, the strength is very important.
Yes, sir.
But to get the strength, you have linked it up with the curing. That is also an inherent part. Today, the curing is becoming more and more scarce, and we are trying to find out shortcuts in limiting the curing. There are n number of queries which come up and say, sir, how many days of curing can I do with the minimum? When we were taught 28 days curing. It is not that 28 days curing is the maximum. Curing, as per the structural requirement, the properties of concrete, it continues, the gelation process and the strength gain continues for a period of more than a year. But then we have to go draw a cutoff point somewhere. So it was 28 days. But now he says, sir, 28 days is also too long. So they make it 15 days. Somebody says 1 week. So there is no end to it. Yes, there is a way out, and that is the use of curing compounds. Curing is the cement concrete without curing is powder, is of no meaning. Whatever designs, whatever points that you may consider, you have to, curing is the single most important thing. So there is no denial in that. And I have only made a passing reference when it came to 53 grade and 33 grade of cement. Probably 33 grade cement, the entire amount of the cement particle was not hydrated, and that is why the strength remained only to 33. But by making it more fine, the more of cement was hydrated and greater amount of strength was created. It is not related to curing alone. Is that clear, sir?
Yes, sir. Yes, sir. Yes. The idea is very clear.
Microphone
Thank you.
unmute.
Thank you.
इसका तो sound ही उड़ गया.
Yes, please. Please.
No, please.
Come closer, you will not be able to understand what you are saying. Idhar aa jao, don't worry. I've got a hearing problem, so that's why.
I'm saying that in the section theory of cracking,
Second?
theory of cracking, you said that the beams must develop cracks in order to transfer the load from the to the columns to the reinforcement. So I'm asking that how can we limit those cracks within the permissible limit? Because you said that if they exceed the permissible limit, it can be a disaster. And
Yes,
if they are in permissible.
A gentleman has asked as to how do we restrict the cracks. Now, cracks, if you go to the IS 456, the limit state of design covering the crack width, you will come to a situation where the particular design combination gives you a certain crack width size. You revise your design in such a manner that the crack width is coming to the controlled size, right? It is not a thing that you just leave it to what is happening on the ground. No. You have to design. That was the aim of mentioning. It is not that something has happened and then you are going to work back. That is a matter of rehabilitation. But as a matter of design, I said keep the limit state of crack is also a very important stage. If you design your structure for your limit state of crack, it will certainly come to a situation where the cracks are not going to occur. All. So thank you very much for that patient hearing. And I shall again be talking to you tomorrow. The topic will be the sealing of expansion joints. Thank you.
अच्छा
Let's start. Okay, good afternoon and welcome back after the your lunch break. Now we will be having one session on defects in structures. Particularly, we will be talking about what type of defects occur in your buildings. Basically, when we are talking about structures or any say particularly RCC building, it is assumed that the service life of that particular structure will be around 100 years. But at the same time, you will see our examples from our daily life. You will find that okay, there are many old structures which are standing since centuries, or there are structures which are only few years, say 2 or 3 years old. Okay, they have deteriorated to an extent that they are not even service giving that service for which they have been designed or which have been constructed. So there are many factors on which your construction this life of a building or life of a structure will depend. Particularly what type of a construction is there, if it is a temporary or it is a permanent construction. Then quality aspect is very important there, the quality of construction, both what type of a material has been used and at the same time how good is the workmanship. And then what type of a loads are there, if there is a any change in the loading conditions, whether we have put some extra load or some other additions have been made which is causing the building which is bringing extra stresses in your structure. Then you have to see that while during construction itself we make many there are structural deficiencies like improper size of column, hidden beams. We provide sometimes column floating design, sometimes we give the wrong detailings, and sometimes we provide the under design section. Exposure conditions, they are again important, how in what conditions basically the structure has been constructed, whether the weather conditions are severe or moderate, or you are and what type of a rain is there if it is in coastal area. So and then natural calamities, again they cause damages like earthquakes, cyclones, landslides, fire, etc. Then your natural aging process, with the age also there is a deterioration, and many we have done some alterations, and lack of maintenance. One of the major problem is that okay, we don't basically have the proper maintenance with our buildings, and which cause leakages, and sometimes you find some vegetations on the rooftop, etc. So when we are talking about how our structures deteriorate and what are the factors, basically one of the environmental factors are very important here. You see that your presence of carbon dioxide, acidic environment, oxygen, exposure to sunlight, water, different salts, and then your sometimes your building is exposed to some severe type of waste water, and then you have the pollution from air pollution, say pollution coming from some industries and gases coming. So all these factors basically, they when the building is exposed to those conditions, it starts deteriorating. It has its own effect on this thing. And so if these factors are taken into consideration, they are attacking our building, that means what we will observe is there will be disintegration in the concrete sections. In the this thing, you will find corrosion and spalling. you will have cracking, you will have leakages, natural many times wear tear, sagging, buckling, many deflections, expansion, settlement, etc. are the issues which basically lead to that which cause certain type of defects in your building. This thing. So and you see the if there is a provision of say cracks are there, and that any type of a crack, basically crack is a, I always say it is a symptom. Symptom means that okay, if you compare it to your human body, you have a temperature. Once you are having a temperature, that means you are having some high temperature is there, or the cause of temperature, maybe diarrhea, maybe you are viral inspection, maybe you are other. So that means the cracking in a structure is a one visual sort of from visual this thing we have to find out the exact cause of the this thing. You have to carry out a diagnosis properly. So when we come to this non-structural testing part, so there we will be discussing about the proper diagnosis requirement, but and then it is always we should remember that stitch in time saves time. So preventive maintenance, it may cost less as compared to your regular repair and rehabilitation cost. So basically you can see that here this graph is there. If we are seeing this graph, you can see that complete if failure is there, so it cost is very high. If normal wear and tear is there, this normal wear and tear is there, so so total cost, you can say major repair is very high sometimes, but if you are carrying out the preventive maintenance, you with the reference with respect to a minor and major repair, you will be able to achieve the proper function of the building within a reasonable maintenance cost. So and when we are talking about the cracks in structures, you can see that there are two types of cracks. One are the structural cracks and non-structural cracks. Structural cracks are basically as a result of you have the incorrect design. I think morning we discussed design considerations in those things. So when we are sometimes we provide not adequate reinforcement in the structures, or sometimes our say concrete is not basically of up to that grade. We provide some many times smaller members, not enough size of the members are there. So then faulty construction. Whenever we are having any construction, this thing, so if we may not have provided proper construction joint, we may not have provided proper say as per reinforcement as given in your details and all that, and you have the overloading conditions, incorrect detailing, incorrect assessment of the bearing capacity. Then your foundation movement and settlement of the soil is one of the major reasons, and corrosion is again, you can say it is a cancer to your structure, like a cancer. And then non-structural cracks, if not attended to, they get converted into the structural cracks. But non-structural cracks are maybe there due to moisture changes, thermal movement, elastic deformation, creep, chemical reaction, foundation movement, and vegetation growing on this thing. So you will find that the major, mostly the 80% cracks are non-structural cracks, but 20% generally this thing you can say. But any this non-structural cracks, if not attended to, so they will get converted into the structural cracks later on. This we will leave. So as I said that from your visual observations, what type of a crack is there. From there you will have to further investigate, carry out your conclusion that okay, if the pattern of crack is like it is shown in the bridge here, this is if this type of a diagonal cracks you are getting along a regular this thing, so that means this is the shear failure. The shear reinforcement provided is on the lower side, and that is causing this type of cracks. So if you go to a site and visit basically your site, there you have to see that okay, what is the pattern of cracks, and from the pattern of cracks you will be able to conclude what is the cause behind that crack. And in any building repair or maintenance program, it is important that okay, we accurately diagnose the cause behind that particular sort of a deformation. If we are unable to basically properly diagnose the problem, cause of the problem, then I think our remedial measures will not be effective. So so you are depending from the pattern of cracks, you have to you can find out okay, what type of cracks are these? Are again shear and fracture crack, they are shown here. So both are this thing. Yeah. Then you can see the more closely what when the your concrete is swelling in fracture this thing. So what type of cracks you are getting. So this is again the fracture crack in a beam. In a column, you can see the pattern of crack here. This is again tension cracks in it. Your reinforcement tension reinforcement product is not proper. So you are having a this sort of a pattern crack shows that it is a tension cracks in your columns. These are compression cracks failing due to compression. Yeah. These are settlement cracks. When it come on in mostly load bearing structure, you will find that the foundation is settling, and you will get the diagonal cross starting from one corner or from say one corner of a window to the ground this thing. So there you from there you can basically find out, okay, this is the due to the settlement of the ground. And many times why settlement occurs, sometimes you have assumed the you are built a building on a filled up area, or there is maybe some clay this thing which is having a which is getting a water coming in contact with the water, and that water is causing the your expansion and contraction of your say soil below, and this is again leading to the foundation settlement. And how you can see the building affected by the your structural this foundation settlement. Again the same. This is again the pictures which show the different types of. This is external ground settlement is being shown here. How that your externally the ground is settling. Again that diagonal crack here you see is again is the reason is your structural cracks. Again that ground settlement has taken place. These are just views, and one of the good examples again, when you are going absorbing the settlement, you must see there were traps outside. The gully traps and all that you are provided, you will find that they have, and manholes you are provided, you will find that okay they must have the cracks or cracks and all that. So from there you can conclude that yes, your plumbing lines and they are there. So if they get damaged further, your water, again the seepage of water will be more, and more of the problems will be occurring into your structure. Okay, not this thing we have yesterday we discussed these earthquake damages. Again this is the columns, you can see that. And one of the major problems in most of the building is the corrosion. When we are talking about corrosion, you will find that corrosion generally occurs in a building due to two reasons. One is your if the excess of the colloids are present into your concrete, or if there may be carbonation. How you can differentiate between a carbonation related corrosion or a colloid related corrosion? Carbonation related corrosion, if you see that the crack will be along the bar, and in case of a colloid related corrosion, you will find that there is a there is no sign basically, but will small spots of corrosion will be there in a one particular section. And small corrosion will be there, and those will be small and what happens that inside the the bars are getting corroded, and the bond between the bars and the cement this cement is breaking, and suddenly one day your concrete will come out. Whereas in this case, in case of a carbonation product, you will find the enough visual signs of cracks along the bar, and you can take the appropriate measure. So in that colloid related corrosion, the failure is sudden, whereas in case of a corrosion related this carbonation related corrosion, the enough warning is there before collapsing. And how would I think you all understand what is the carbonation this thing. So carbonation is the phenomena from phenomena basically which affects our structure is when the concrete is permeable, concrete or your porous concrete, and that due to the weather condition, due to the humidity, temperature, and ingress of your carbon dioxide, etc., your gases are entering into your concrete, and what happens, the you already there is a calcium hydroxide into the concrete, and that calcium hydroxide, when it reacts with your carbon dioxide, it becomes a carbonic acid. That means, and as all we know, the alkalinity of the concrete is very high. It is in the range of about 13, and because formation of the carbonic acid, your acidity, your alkalinity starts going down, and when it reaches say 11, 9, or when that ingress basically starts from the cover, that is why the cover concrete is very important here. The cover to concrete is very, carbonation in itself in a concrete is not any problem, but when carbonation reaches up to the bar level, where your reinforcement is provided, okay, so from there the corrosion will start, because that what happens, that when this there is a ferrous, that ferrous when reacts with your this this thing, so it becomes ferric. The ferric is nothing but rust, and when the rusting starts, your bond between concrete and your this starts failing, and your spalling will start and all that. So this is, and whereas in a chloride same phenomena occurs, but it is happening inside, because chlorides are already there in there is no ingress from the outside, but inside that ingress is taking place, and that is causing the so this is what you can say, the column badly affected by corrosion, usko jo hai, they have tied it with the bars so that further doesn't take place, that collapse doesn't take place, but this is not a solution to this. Okay, this is the one figure you can see that here. Where your corrosion has already causing the the concrete as spalling, and concrete has come out from your this place. This is again badly affected slab, which has been supported otherwise to give extra support, but it is not going to have any sort of a solution basically. This is the one again badly affected your this thing. This is again corrosion cracks. Again, how badly the column is affected by corrosion. You can see these columns, these staircases, very severe corrosion is there. Similarly, here you can see that there is a gap that has occurred. Your reinforcement has almost completely 100% it has disappeared from because of the corrosion only. And the one, this is again. And generally what we do is that in many times I have seen that, okay, whenever you are having this sort of a problem, so without attending to the cause, without removing the cause of your this thing, that is a fresh say plastering is done over the bottom of that surface on the this thing, and maybe some reconcreting is done, recovering by concrete is done, and that is not a solution, because after some time the bonding will again thing. Only thing is we have to protect the concrete while treating the corrosion. So what we have to do is we have to give enough protection to the reinforcement bars, reinforcement bars, where we can provide some anti-corrosive paints on that surface, and then you can do the reconcreting. So if it is not, if the bar again comes after repair in contact with the carbonated concrete, your corrosion phenomena will start again. So we have to be very careful that the concrete around the bar is, whenever we are repairing, that is not the carbonated again. So that factor we have to take into consideration. Okay. So corrosion structural member is again the same way. And you will find that many times tree grows and all that on our rooftops, or maybe in our say retaining walls, etc. These are shrinkage cracks. We have not provided this thing, though they are reversible, but again they are the cause of say entry of your water into your structure, and again leading to corrosion afterwards. This is one. And this is a bottom of a groundwater tank which has been badly this thing. So and this is again a water tank, groundwater tank, This is the overhead tank where the due to chlorine gas already present there, that has and then the quality of the concrete was poor, so zero cover was there, and that is again have collapsed. Sulfate attack is one of the very this thing. So you can see that from the how the pattern of the deterioration due to sulfates in glass. Because what happens if sulfates are there, so they will cause the volumetric expansion, and due to volumetric expansion in the concrete, this type of a cracks will appear. You can see this type of a cracks, they will appear in the you can see completely gone. We about 10 years back we tested 2 water tanks in say in some particular area in Punjab. Exactly, I will say that in the Fazilka or that belt was a Bhor belt was there, where sulfates from the ground they rise to this thing, and you can and there we understood the importance of your cover. What happened? The 2 tanks, they were constructed at the same time. No difference in the material of construction. Same concrete was used, same everything was used. But in one tank, the concrete cover was proper, whereas in the other tank, the concrete cover it was not proper, and some maybe this thing. So that tank deteriorated to that extent where it has to be reconstructed again after demolishing the one. Whereas the other tank quality was almost as good as it was new. So and the workmanship, that is very important there. The salt attack, how it is affected, a concrete gets affected due to poison of salts again, like chlorides and sulfates and all that are there. So they are the one. This is again alkali aggregate reaction cracks. If you are having the aggregates where they are having that reaction takes place due to alkaline nature of your aggregates. So you will find again the steps similar to your sulfate attack. Then your lifting stress cracks, okay, where you have provided some extra this thing, so there you will find that okay, these type of cracks are there. Then vegetation. Many times you will find we don't basically remove the particularly the people trees, which they either they grow on wall or they grow on the rooftop. We allow them to remain there, and their roots they enter into your concrete in this thing, and they start causing problem of leakages and corrosion later on. This is a very, you can see these are real pictures taken from a site, and you can see that due to the your this bottom of this thing. So already debonding has taken place here. Okay, top vegetation on the terrace, as if you are growing a jungle there. Okay. This is due to the leakage has taken place. Many times from the top, from the joint of this thing, your column beam or other joints are the places they are not properly plugged, and leakage has taken place, and this leakage is causing you this thing. So you can see that the building affected by leakages. It's common scene at many places. You can see how. So basically that type of your waterproofing provided is also basically will determine whether how much seepage will take place. I had a very interesting example to quote here. Our own houses of the campus, they were having this type of a tile terracing, and were a major source of leakage because the life of your mud fusca type of a treatment, which is we are seeing here, which is done in this part of the country, is about say 5 to 10 years, not more than that. Because in what mud fusca, what in any this thing we do is we provide a bitumen coating at this thing, and over that we provide mud fusca, and then we provide these tiles on the roof for this thing. And this is not a waterproofing exactly, because life of your bitumen is about not more than 5 years. So once water start entering through your joints and all that or those things, so it will go this thing. So basically our own roofs were having this type of a construction, and after we are getting a lot of complaints from the residents regarding the seepage this thing. So what we did is we floated a tender, with this condition that okay, that wherever the mud faska is removed, mud faska is having not a proper slope, and tiles are not good, so they are to be replaced. So when the tender was allotted and the work started, so that man basically removed almost complete thing, but without redoing the bottom part, because it was difficult to remove the bitumen this thing, because that requires a lot of preparation, all that grinding and all that. So he didn't do that. And when the rainy season and the work was done in the month of April, when the temperature was high, without he didn't had those sort of in the joints whatever, he didn't carry out proper curing also. And when the rains came in your this rainy season, the situation became something like that. Okay, within a period of 5 minutes, that water could be one bucket could be filled when the rain was there. And it was not in a one room, there were 3 bedrooms in the house and one drawing dining, so whole the rooms were leaking like that. We didn't do how to do that, what to do that, but any case what we did is immediately this thing, we on the rooftop we took the this thing burning agent, made a cement slurry, and with the help of a brush we applied that cement paste on the top of the bricks. It worked for this thing, but when there till the time there was no sun, but as the sun came. So another one of very important property, I think this may be discussed during our discussion also, of a waterproofing material is breathability. That any waterproofing material has to be a breathable material. That means if you compare it with your skin, what happens, your skin's having a pores, okay? And whenever you take a bath, the water doesn't enter through your skin. But whatever you are, if you are sweating, that comes out. So that is a term is a breathability. That means that any waterproofing material, outside water should not able to go inside, but whatever the inside water is there, that should go out without causing any say cracks or any this thing. It should just, so that sort of a, so but this cement is not having a water breathability. That means it was not breathable. So that again the when the sun came, the water started evaporating, causing again cracks in the building, and when again the rain came, it again started this thing. So that solution was not effective, so we did something else afterwards. What we did is, okay, as a solution of later on, we, because as a government agency we have to see that the cost doesn't go up. There were no funds available, we can't ask funds again from the government, because already we have spent on that machine. So we did one thing, we were having some extra cement, so we requested asked the contractor that okay, what you do is we will have a ferro cement layer on the top. So what we provided a 3-inch ferro cement layer with the proper this thing, putting the integral waterproofer, and at that time some fibers, so that to avoid the cracking, shrinkage cracks and all that also. So it worked, and since last 20 years this sort of a solution is still working there. So that is what basically, so so waterproofing is important, and many times we do this sort of a put extra plumbing and pipes etc. into this thing. So this is not a proper way. Input connections are provided. Choking of the manholes, it may lead to the adjoining ground settlement. That is what I said initially also. If the water is going into this thing, it will change the water conditions and will cause the settlement. Blockage of the rainwater pipes at the rooftop, one of the major concerns. This is because we are not carrying the regular maintenance. We are having a one very central government organization in Chandigarh itself, where the roof was of a folded plate type roof. I think you understand what is folded plate. You have a sort of inclined this thing, and then you have a horizontal channel which is provided to drain out the water. So all the side, like here you are seeing here, is all the rainwater pipes provided, they were blocked. The water was seeping this inside this thing, and it created so much of corrosion in their buildings, in the beams and all that. So complete roof has to be again relaid basically. So this is what again the situation. Many times we do this, just If there is nothing else is there, we resort to such type of condition. Very common sight: overhead tanks leaking, water stagnation. And then I think morning we had a session from external sources like vibrations. So vibration for our machines, DG sets, pumps, building or joining to the rail tracks, building near to the rock mines, blasting areas, very close vicinity to your unsafe structures. Then possibility of ponding or joining building during earthquake. Again, this is a one very common site. Column offsets. We tested a building, say 7-story building. The cause was something else because there was some dispute within contractor and client regarding payment with respect to your grade of the cement. In drawing they mentioned the grade N15, whereas in some other places they mentioned the grade as per IS 456, which means that it should be M50. So there was a dispute, and the party, there was arbitration case going us, and we were asked to check the grade of the concrete. We use some non-substitute testing techniques, but when we were carrying out that technique, this thing, we found that the column from the plinth level, they have been given this type of offset, about 50 mm offset was given, and that created again a lot of problems. So this is a very common problem. Again, a construction defect. You can see how the columns of the staircase have been having the offset, right? If you go from this to place, any place, so every floor is having different. So cold joint is again one of the distinct problem in any building. The one concrete is a honeycombing concrete, or proper concrete is not there. Your grade of concrete is not properly laid. Leaching in the concrete, fluorescence, it is salts having more than salt, so whatever the leaching coming out, you can find it is causing this thing. So many a times we carry out some additional alterations, like we puncture your RCC members to fix the electrical and plumbing lines. We convert balconies into toilets. We construct walls on the slab. We carry out modification in the framing system. We have a removal of walls and extensions of your various members using double wards, etc. So we have to be very careful when we are doing such type of this thing. So this is one example: wall which have been constructed later on without any beams. So it will stay. We have made a hole for you are carrying the duct for your AC. So this is what we have. Many times we puncture the RCC columns. Defections in the beams. You can see from here. You can see that how much beam has deflected. You can see difference between this thing. Visually, you can find out. Okay. Okay. Large slabs are there. Flat slabs have been provided, so they deflect more. Generally, what happens that okay, design assumptions are different, actual site conditions are different, and what happens that okay, we provide some extra flooring thickness. If it is recommended is 40 to 50 mm, we generally end up providing 100 mm. Waterproofing thickness is 100 to 150, where in actual practice there is more. That means it is increasing the dead load of the building. And again, I think many times we provide the extra platforms, extra tanks on the building. This again, balcony have been converted into a room. Enclosing balconies, standard thickness of the floor is more. So design assumptions, these are different. Then structure collapses are basically this thing, you are result of this thing. So unstable structure you will find. So they will lead to your this sort of a problem. So these are the generally type of defects we occur. They are occur in your building. And as I said that okay, it is important that when we how to investigate them. So we have seen that yes, there are different type of defects in into your building, and whenever we are to carry out your building this thing, any investigation also, so we diagnose this thing. So proper investigation is very important. So we have to ensure that durable buildings, and we have seen that these type of defects occur due to the threats to the durability, and which basically the results in the form of your some delamination, cracking, shrinkage, and chemical listing. So we have to see that okay, whenever you are building, so there has to be properly this thing, and we have to ensure that your cement aggregates, concrete ingredients are very in a proper this thing. Your process of concreting has to be proper whenever you are doing your batching, mixing, transportation, placing, compaction, finishing, because these concreting is a chain of a many this thing. Your batching, mixing, transportation, if you see a chain, if in a chain, if you find any link is weak, so that means that okay, that it is going to cause the problem there. So whenever if you mixing has to be proper, placing is to be, compaction is to be done properly, curing is to be done properly. So all those things, so we have to see that what type of a cement, its properties we have to determine. So whenever we are doing a mixture, where we are using, and but ultimately if something happen, so yeah, so any type of a defects if occurs in the building, because any structure is there, it is bound to deteriorate with age, maybe as we discussed, due to environmental factor, due to design factor, due to construction problems, due to workmanship problems, or something this one. So our investigation is very important. So basically we have to carry the investigations, and when we say investigations, so investigations we will cover that your visual inspection, your non-substrate testing techniques, chemical testing, permeability, rebar studies, corrosion studies, etc. is to be carried out at the site. We have already seen that okay, if this proper detailing is not done, okay, proper at the site, bending of the hook, inadequate anchorage, not done, the detailing, your all these your construction quality is to be proper. Okay. This is again the photographs which shows that different type of a rusting due to chloride. So we have already discussed these things. So basically we want to see that okay, how to carry out the investigation of these type of defects, and the techniques available are okay. It is not there in this. Yes, this is a particular thing in which we have discussed the various type of tests which are done there. So we will not discuss these tests here right now, but we will be definitely discussing the non-destructive testing techniques. So we have seen that the various problems in the buildings are due to your concrete strength is not proper, or it is having some honeycombing or some internal flaws, or there may be some sort of a salts which are causing the cracks in the building. So how to carry out the structural assessment, it is important, and the non-substitute testing techniques are the type of a techniques where we are not causing any damage to the structure. Without causing any damage, we are carrying out the assessment of the structure, assessment of your maybe strength or maybe other parameters which are required for our investigations, that we are determining. and I will say that our non-structural visual inspection is a part of your non-structural testing inspection technique, because once you go at the site, as I said, you determine the pattern of the cracks, what type of cracks are there, what is their pattern. From there you will be able to find out whether this is a shear failure, whether it is a corrosion related to carbonation, whether it is corrosion related to chlorides, or maybe shear cracks, or say fracture failure, etc. So from there we will be able to find out and decide, okay, what is this thing. But in any case, when we are carrying out our this sort of investigations, I think in any sort of a damage assessment, it is important, the parameter which are important is in situ concrete strength, your reinforcement provided, what is its condition, what is the cover to reinforcement, because once we are letting it correlating with the carbonation, cover becomes important. So so cover to the reinforcement, and these are the parameters basically which basically we determine using this sort of this thing. And so so conventional assessment methods will have many limitations due to new generation material construction techniques, but non-substituent techniques, they are handy and they can be used effectively to carry out the in situ assessment of a or condition assessment of a structure. And many a times nowadays it is important also for many buildings also, where they are required to carry out their condition assessment after every 10 years or maybe after every 5 years. So NDT plays a crucial role in inspection assessment of a structure, such as your pipelines, your water tanks, power station, refineries, etc. So they can be used for both new and as well the old structures, and then they can be used for quality assessment, also for damage assessment also. And then they are there is no single technique basically in non-structural testing technique which can give you a tell you basically that you may have to use one sometimes combination of methods while carrying out the assessment using non-substitute testing techniques. And there again the methods basically we are using, depending upon their methods for assessment, you will see that the methods may be non-destructive, semi-destructive, or completely destructive method, depending upon it has caused that your assessment has caused damage to the structure. So NDT test covers testing right from your assessment by the naked eye to advanced technique available for testing of the structures. It is only applied in quality control and routine inspection, but also in diagnostic investigations also. Okay, both are this thing. We are this thing. In this then I will show you after one more presentation maybe. But here I have discussed commonly used methods here, which are very commonly used in our country or for this thing. So the methods which I have listed here is Schmidt's rebound hammer, ultrasonic pulse velocity, performator reverse testing, resistivity meter, half cell potential meter, core test. Even this pulse echo, pull out and maturity testing techniques are there, but they are not very commonly used. So the Schmidt's rebound hammer test method is basically it is used to determine the in situ compressive strength, whereas ultrasonic pulse velocity method is used to determine your presence of cracks, voids, or honeycombing, etc. into the concrete, which and then your performator and reverse scanner is basically give you the cover reinforcement, details to reinforcement like its bar, dia, spacing, etc. Resistivity meter and half cell potential meter test, they give you the corrosion extent of corrosion in your structure. Core test is again a partially destructive test which gives you this in situ strength. Pulse echo and this pull-out test are again nothing but they are pulse echo test is nothing but ultrasonic pulse velocity method basically used for determining the integrity of your piles, which is also called the pile integrity test. Pull-out test is again used for determining the compressive strength, and maturity technique is an in situ testing technique to observe the development of compressive strength of a freshly laid concrete. So generally objective of the non-substitute testing is the determine the quality of the your this thing, then evaluate the structure. If you require, evaluate the structure whether you want to carry further strengthening, whether it will be able to carry out any extra load or any extra building to be casing, or sometimes you may not be having your design drawing details, etc. So there these your evaluation structure is required. And then I said it is again the condition assessment has become mandatory in many of the buildings, so there also your evaluation structure is required. Then many times it becomes important to estimate the compressive strength of the concrete, identification of cause of damage and source of the problem, then determination of the material properties of the material properties, then determination of the extent of damage, assessment of safety and serviceability of the structure, formulating remedial and preventive measures, determination of position, quantity and condition of the reinforcement, estimating the cost of repair and replacement, increase the confidence level of few descriptive testing techniques, then structure evaluation after repair also. So this is the I will show you another thing, but here I think I have discussed only very commonly used test. So one of the commonly used tests is the very commonly used test and very quick test is the Schmidt's rebound hammer test to determine the in situ compressive strength of concrete in any structure. Okay. So and another important thing in case of a non-safety testing technique is that these tests doesn't basically they determine one particular property. Like if you are in case of a rebound hammer, you are determining the hardness of the surface, and that hardness has been indirectly correlated with the strength. We assume that harder is the surface, more is the strength. So based on that, basically we again that is what that okay we are determining one particular property and which has been correlated with our other parameters of this thing. So in case of a rebound hammer, it is used to determine hardness of the concrete by measuring the rebound number. You can see that here this is the rebound hammer which is having one plunger. There is a spring here, there is a hammer here, there is a latch here, it is a body, and there is a indicator on the surface which is having the numbers 10, 20, 30, 40, etc. So this is a basically plunger is hit against the concrete surface, and when this plunger is hit, this mass, because of the spring action, it is rebounds. That rebound is recorded by this indicator here, and this indicator when it comes back, so it will show you some value. That value you directly read from the your surface. It may be 10, 20 number, 30 number, 40 number, something like that. That has been correlated with the strength. So it is called the rebound number, and that rebound number can be directly read from the graph by either prepared by you or from the manufacturer standard graph given. So you can directly predict what is the strength of the concrete. So this is the say commonly this thing, and there are nowadays you can see that most common type of hammer, but I think this is a microprocessor based hammer. Nowadays you have the digital hammers which are having all the good this thing. So basically as I explained, that when the plunger of the rebound hammer is pressed against the surface of the concrete, the spring controlled mass rebounds, and this rebound is read off along a graduated scale and is designated as a rebound number or rebound index. Okay. This is a just internal structure. This is the plunger here, this is a spring, this is your rebound mass. Here is a scale, here is a number 10, 20, 30, 40, 50, 60, 70, 80, like 100 this thing. So whenever this rebound mass comes back, this will indicate some number, and that number is raised against your this thing. So this is what basically we just shown the working here. You attach one end to that microprocessor. Here they have the on off button. There you can feed the data, number of readings to be taken, like either 6, 7, 8, 9, 10. So generally the exact method to do at the site is that what you do is you select, and if there is a column this thing or a beam is thing, you select about 5 to 6 locations. On that 5 to 6 locations you make a area of 1 feet by 1 feet. In 5 this thing, clean it properly so that there is no extra loose say concrete or loose thing is there on the surface, hit it at 10 locations in that particular this thing, and take average of 6. Discard very high to discard very low 2 numbers also, and take the average of 6. So do it at the 6 locations and take average number, and then that gives you the average rebound number. So average rebound number will give you the strength basically of that particular member. So this is how this is done. So this is from there your menu, from you can feed number of say average to be taken. You can feed other data about your this thing. So from here you can do that. But nowadays you have a better this thing. Your this values, I think from the menu you can track the impact direction, because earlier were hammers, actually the routine type of hammers, the impact direction is important, but digital hammer which has been now been introduced, the impact direction is not important. You can directly read the reading rebound number and directly read from the this thing. So basically impact direction, your mean values, whether 6, 8 or round number, your serial number, your conversion units, or your you can select curve also. Either you can cut this manufacturer fed curve, or you can generate your own curve basically by testing on the cubes. So in any case, the calibration of your instrument in case of a non-substitute testing is very, very important. If you have calibrated it properly, good. Many times I think I have seen many times when we go to the site to test the this thing. So the first question the client asks is, what is the accuracy of your this thing? Whether you are if you are getting the giving the compressive strength using this, how accurate is this? The best thing is whether you keep your this hammer calibrated and tested on cubes which you are testing in your lab. So it will give you a very nice thing. So what happened that, okay, recently we went to a site where we had a hammer, a concrete of M60 grade, and that was got tested by some other hammer thing, and they have given a failed report basically. That okay, they gave the strength is concrete is not more than 40. And when we tested our using our hammer also, so we before reaching there we said no, it is having a strength of about 62 this thing. So the other party came and they said, okay, how you can say? Then they brought a cube and said, okay, you tested on this particular cube. So whatever one about we said, you okay, he said, okay, no, tell what is the strength. So we said it will be 50 plus minus 2 something, and at the site so how happened it was exactly 50. So basically that your confidence of doing this thing is very, very important. How you are keeping your hammer or your rebound hammer is in a calibrated stage, it is important. Basically when you are purchasing your rebound hammer, you get a one say part of that is what is called the anvil. So on that anvil you keep on testing your hammer rebound number on a routine basis. Because the depending upon your cost of hammer and your say quality of the hammer, generally the your spring basically that is the main material which is the main part of your hammer is basically it keeps on working for a longer period. But the cheaper hammers, the basically spring action basically that may not be there for a longer period. It may basically lose its elasticity or whatever you are basically that expansion and this thing in a faster way, maybe in 1 month, 2 month, 3 month it may not work. But the good hammers, yes, they work for a longer period, and keep on testing on your thing so that when you are testing it, using it, so you get a standard value on that anvil, and once you have that standard value exactly coming, your hammer is actually calibrated, so you can basically give the results on a very high confidence level. So this is what we are testing the hammer. This is the graph basically which is coming. You can see this is the graph is on this is the 0 degree angle, this is minus 90, this is plus 90. So as I said, that digital hammer which has been now introduced, it is either a single curve only. You can feed, you can directly read from the this thing after thing. So the values which affect the rebound values are the type of cement, type of aggregate, surface condition and moisture content of the concrete, curing and age of concrete, Carbonation of the concrete surface, because carbonation, when carbonation is there, your surface will become harder. You will get high rebound number values. So you have to take the correction factor there also. Okay. Then there are different type of hammers. That the commonly hammer which I have shown is the N-type hammer, which basically will give you the which is suitable for strength ranges from 10 to 70. This thing. But then sometimes you may have a hammer. This is again the no. This is not coming. This is the self-recording type hammer where you need not note down your rebound number. It is a graph attached, and from there you can take the average of your 6-7 readings. Is how. And this is another P-type hammer in use. Basically, this hammer is used to determine the strength of very low strength concrete, maybe up to 5 Newton, and also for brick masonry and for your plaster work also. That can be used, and here the principle is same. You can say this is the instead of plunger, this type of a plunger is given here, and there is a hole here, and you can select whether in the particular or in this thing. So this button you can see here. यहाँ से आप उसको जो है पुश करेंगे, इसको ट्रिगर करेंगे इसको. तो ट्रिगर करने से क्या होगा कि ये जो है it will hit the surface here and rebound back. Depending upon the hardness of the surface, you will get some reading like 10, 20, 50, 40, 60 also, and that reading is again read from the graph, which will give you the strength of that particular this thing. So it is again a good equipment where if sometimes many times you will find that okay, there may are doubts of the plaster quality also, whether the plaster ratio is 1:3, 1:4, 1:5, 1:6. So basically what you can do is you can calibrate your hammer to different numbers in your lab, and then go to the site and test it. Basically you will get a very good ratio also for your this work. Maintenance. This is the rebound M-type hammer, which is used for mass concreting work like your dams and air pavements, etc. It is having a higher plunger value because your depth is more. These are the different type of hammers. You will see this is the anvil I was talking about. Here you can hit it on the surface and standard reading should be there. That means if you are getting on that, your reading is correct. This is the digital type hammer. What I was saying that okay, nowadays, and this is that microprocessor paste. This is P-type hammer. So all those type of hammers are there. You can basically use them for your different this thing. And many times to quality construction, we got a case here about one this thing, and in that particular situation, what happened that they have casted a pier of a bridge. And that pier of when they were testing the cement, they found that one particular sample of cement has failed. No, it was not possible to find out whether that cement was in which location it was used, in which basically height and at what height it was used. So there we used this rebound hammer and found out where the value was giving low. So that area was selected, and that was after growing it was rehabilitated again, and it worked basically with that on that condition. So that is one application. If you are having some doubt about some place, this hammer can be used to identify that particular thing. So you can see that the advantages of this is a very simple, speedy and inexpensive method. Once you have purchased a hammer costing about 2.5 to 3 lakhs, so you can basically take thousands of readings and using that particular. So one plunger will give you about 20,000 to 30,000. Which plunger need to be changed after every 30 or 20,000 readings, and the cost of the plunger is about 15,000 actually. So with that, I think whenever we are using our hammer is, I think we have recovered our cost by carrying out the different consultancy projects at different locations. So it's a good sort of a system where if you are doing it properly, and many times when you are carrying out your non-surface testing technique, it is important. 50% I will say it is your instrument, and 50% is judgment of the person who is doing that. It is important because how at what location he is doing that particular thing. I again give you one example. We were having a building, one particular building which was given to us, and we were to test the strength of that particular in the columns. So we went at the site, tested the strength and gave the results. And that again, that building was got tested through some other agency also. They have given the report. We gave a report that okay, this is the corresponding to M20 grade, where other party has given the report that the strength of the concrete is poor. So we thought okay, then we both of reached at the site, and we said okay, see what we have done is कहाँ पे हमने किया है. So what we have done is we did the testing on the good columns on a good surface area, whereas the surface area which is having cracks and honeycombing etc., that was not basically tested by this. So we, and in our report we have mentioned that okay, that areas where honeycombing is there, where cracks are there, it needs to be strengthened, but otherwise the overall strength of the concrete in case is corresponding to this grade of concrete. So we were also correct and they were also correct, but thing is that okay, how you have, so the person who has carried out that test is his judgment and his basically how he attempts the problem is important here. So purpose of your, that means your objective of carrying out test is very important. So first the person who is doing the test, he should be very clear what is the objective of carrying out that particular test. Okay. So and here you see that it is a good this thing, but its limitation is expensive and inexpensive and speedy method. In a day you can cover almost a large part of a building, but the limitation is it gives compressive strength up to limited depth on the surface. Only it is telling about cover concrete, and we are assuming if cover concrete is good, inside concrete must be same. And the code says accuracy is plus minus 15% to plus minus 25%, but plus minus 50% if you are testing the cubes also, even they say that okay, within the range of plus minus 15% your results are acceptable. So same is the case here also. It is the accuracy I can say as compared to your cubes, and it is again the same this thing. So this is the one method to determine the compressive strength. Another method is which I have not shown here. Maybe I quickly go through if time permits me. The other presentation there, the another method is called the Windsor probe method, and then another method and third method is the pull-out test method. So Windsor probe method is nothing but it is a sort of a gun where which we are having a small sort of a pellets, and they are put on the surface of the concrete, and they are with the help of a gun the firing is done, and that pellets will penetrate into the concrete. Depending upon the hardness of the concrete, the penetration, there will be penetration about 10, 20, 30 mm of with that gun. So that penetration, depth of the penetration has been correlated with the strength of this thing. So it is again, but it is not a purely destructive test, partially destructive test, but better than your rebound hammer. And you can basically do carry out that test also, Windsor probe test also, to determine the concrete strength. Pull-out test is what we do is basically what we apply a sort of a force to pull out a one particular part of a concrete from a concrete member, and the force required to pull out that force has been correlated with the strength development also. So this is the 1-2 methods which are no doubt. Core cutting is one other method which is again not a fully destructive method, but partially destructive method, not this thing. And then ultrasonic pulse velocity, UPV, is another method which mainly is used to determine cracks, voids and imperfections present in the concrete. Like honeycombing is there, cracks are there, voids are there. So that so in this method what we do is there is an ultrasonic pulse of longitudinal vibration is provided by an electroacoustical transducer at one surface. Now after traversing a known path, these vibration pulses converted into electrical signal by the second transducer at the same surface, and transit time is measured. And from that transit time we measure the velocity, and that velocity has been correlated with the quality of the concrete. Basically what we do is, this is a type of instrument, this is called the probes. These are the probes, transducers you can say. One is a receiver, one is a transmitter. One will send the wave, other will receive the waves, and these waves travel. They are not able to travel in the air, so they are only travel. They travel in a solid surface. So whenever any void, any crack or any air gap is there, so they will take a longer time to travel. That means we are taking a longer time to travel, your velocity will be less. You can see velocity length divided by time. That means lesser velocity is when quality of concrete is poor. That is when. The methods which are used to determine the velocity are the three methods. One is the direct transmission method, other is the semi-direct transmission method, and third one is the indirect transmission method. Direct transmission method is basically when we have the both faces available to us, like columns in most of the cases. So this is a very accurate method because you are taking scanning whole of the concrete one part to other part, so the accuracy of this method is more. In case of a semi-direct method, yes, we are again taking the path ahead this thing, but not the direct path, because waves travel in all the directions. And then is the indirect path. So indirect path is basically we are talking about surface layer only, not what is happening inside. We are not able to judge it. So that means that okay, this is again your indirect method. Like in slabs, basically you don't have the both surfaces accessible. You can find out from this thing. So pulse velocity and your quality of concrete as per the code, you can see that quality of the concrete is 4.2 to above. It is excellent. Quality of the concrete is 3.5 to 4.2. It is good, very good. You can say 3.0, 3.0 medium quality, and less than 3.0 is poor quality, means further investigations are required. And when you use the method in say combination with your rebound hammer, you can you will find that when you're using this method in combination, your rebound hammer talks about your surface impact only, whereas this ensure the homogeneity throughout the concrete. So that means there the problem of having surface hardness or surface strength only get solved when we are testing the concrete by using. So basically when we are using ultrasonic pulse velocity in conjunction with your rebound hammer, your results will be very, very accurate. These are the two most commonly used methods wherever you see that okay, for strength determination, they are widely used. This is the equipment. This is the one transducer I said. This is the other transducer. Any transducer can act as a transmitter. Any transducer can act as a transmitter. And once you do that, you attach them to your like this. And after this thing, you place it on the concrete surface. There is a on button. After owning the on button, you get the menu button. From the menu button, you can feed your distance and other parameters, whether in meter second, feet second, and all that. So once you start your this thing, and after you are putting the probe, you have put the probe on the surface. You have to be very careful that the surface should be exactly opposite to each other. And once you start this thing from here, push the start button, and start button will start letting this thing. So here the time of travel will be given. This is the distance feeded. This is the velocity obtained. It calculates the velocity. If you are given the rebound hammer also, so it will tell you the strength also. Okay. So you, with that start button, you will start getting the readings. So again, the factors which influence your velocity are the moisture content, temperature of the concrete, path length, shape and size of the specimen, reinforcement. Because in reinforcing steel, the distance time travel is more, and very similar to this UPV for the concrete. You have a UPV for metal also, metallic parts also, and in the only difference is because what happens that the frequency of your sending the waves is very high in case of a metal UPV, but in case of a concrete UPV the frequency is low, because basically the concrete particles are not very loosely packed. Molecules, they are not very loosely packed. So after some time, if the frequency is high, you will not be able to receive the velocity on the other end. So basically the velocity generally used, the frequency range generally used is lesser in case of concrete as compared to your structure. Otherwise there is no difference between working and principle of working of your this ultrasonic pulse velocity system for either concrete or metallic part. And we basically, yes, we have carried out many sort of there was a one railway bridge, pre-stressed box type bridge which was constructed by railways near Chandigarh only. And the problem what happened when this box was being casted, so it was the size of the box was about 22-meter length, 3-meter height, and it was having thickness of 450 to 750 and it was a pre-stressed bridge where cables were to be provided afterwards. What happened that they casted this whole 22-meter by 3-meter bridge in a single this thing to avoid the construction joint, and in that they use the surface vibrators, and so proper vibration could not be carried out. When the shuttering was opened, it was found that there was a huge, large amount of honeycombing, you can say, in that particular in a whole of the box girder, and you can the honeycombing was so high that okay, you could take out the lumps of your concrete from your this thing. So the construction demolition cost was very high, reconstruction cost was very high, and then it was important to rehabilitate that also. So basically, when they came us for consultancy, we tell them okay, we can try by using non-solid testing techniques. So first we told them okay, what you do is you carry out grouting using cement. So they carried out the grouting and prepared the surface. Then we were having the say fresh वहाँ पर जो था material available था. We calibrated our instrument with that material, and we found that for that type of a concrete, that strength of a concrete, it was M40 grade of concrete at that time. That velocity ultrasonic pulse velocity obtained was 5000, and the Bond Hammer number was obtained was maybe a value I can say at 40. So what we did is we divided the whole wall of that box into grids of half meter by half meter and tested it with using rebound hammer and ultrasonic pulse velocity at each and every location, and wherever we could have a velocity of 5000 and rebound value of 50, we said this grid is okay. But if it is not okay, we said we told them to carry out the epoxy grouting, and once they carry out the epoxy grouting there, what they did is the epoxy grouting, we again retested it, and we carried out that exercise till we achieved the UPV value as 5000 and ultrasonic bond number as 40. So whole grids, like there were 100 of grids, you can see, you can divide basically 22 meter by 4 meter into the number of grids of one wall, and there were 2 walls along that, so we carried out a lot of testing and all that, but ultimately the bridge was rehabilitated, and now it is working since last 10 years in a perfect way. So thing is that okay, that is just example shows that these type of instruments can be used for your rehabilitation work, for repair work also. So limitation of UPV are: operator must be well trained, aware of the factors affecting the observations, interpretation of result by experienced engineer is required. When the concrete is wet, it does not give reliable results. When the connection between the probe and the concrete surface is not proper, it gives you. So you have to use the jelly. So that sort of a you can say whatever the jelly or say gel, the working of ultrasonic pulse velocity for human which doctors are using, or which our civil engineering investigation are using, they are almost working principle is same. Working principle is not different, but yes, that type of sophistication and their interpretation, or you can say it has more of a you can say that you can see your software applications are more in case of for accuracy in case of a human body, but yes, they are very similar in working principle. Another type of a instrument is the performeter rebar scanner. Again, many times it happens that your drawings are lost, you don't have the drawings available to you at the site, or you have to carry out the strengthening of the building. We got a building here which was about say 20 years back. It was constructed as a 2-story building, its drawings were lost. Though in that particular grid and all that in Chandigarh, the building height was allowed as 7-story building. So they were not having any drawings of the foundation of the columns or any this thing. So we tested. Challenge was to find out what is the number of bars, dia of the bars in the columns, in the beams, what is the type of foundations in that type of foundation, what is the dia of the bars and all that. So we use this rebar scanners there for finding the cover to reinforcement, for finding the bar dia or spacing of the instrument, a number of bars in the column and all that also. So once we tested it based on our information that a building was redesigned and it has been constructed as a 7-story building also for that particular location. So this type of a rebar scanner and this thing, they are useful for finding the enforcement details. It again works on a principle of magnetism, creating magnetic forces in that particular field, and that because it is a iron this thing, so from that your waves are picked up and you can find out basically what is the dia and what is the spacing of that particular this thing. So basically the instrument is used for locating bar, measuring concrete cover, measuring rebar diameter, measuring rebar spacing. Concrete cover is again important when we are talking about the carbonation also. When carbonation, it is again very important there. So this instrument can be used there also. So this is again the type of the instrument. This is a display unit. This is the probe which is run on the surface. This is attached to this thing, and here you have the buttons. There is a concrete surface which is having the bars and all that also. So on a button is there. Then you can have the menu you can feed the distance like 1 meter by 1 meter grid to be chosen, or 1.5 meter grid is to be chosen, and then you run that probe onto the surface after. So this is what once you start it, you get a display unit, and from here you can see that okay, you will be able to get the dia of this thing. This is how the material is being used. You can see that this is a 16 dia. The result says the diameter of this thing is 16 this thing. So similarly spacing, that has to be located correctly. Basically yes, you have to drawing the drawing and you have to measure it basically then, because once you locate a line here, then you measure it what is the spacing. It may be 100, 200, whatever it is, that can be done by using this particular instrument. So limitation is enforcement less than 10 mm diameter, height and size steel or a deformed bars, etc. They cannot be located accurately. In cases indicated cover is likely to be higher than the true value. Cover measured lower than the true value when special cement including high alumina added pigments are used. Rebars in excess of 32 mm distance may require a recalibration. May not be used. Another, I think, problem, we can say one of the major problems in the structure is the corrosion. And as I said, the corrosion basically is due to ferric iron, colloids, oxygen, water from the concrete and the environment. So the factors which influence the corrosion are we discussed earlier: pH value of the concrete, moisture, oxygen permeability, water permeability, carbonation, dissolved chloride, permeability of the concrete, cover to reinforcement, dry wet cycles, and marine environment. There are two instruments. One is called the resistivity meter, other is called the half cell potentiometer. In resistivity meter, we are measuring the resistance. In half cell potentiometer, we are measuring the voltage, and that resistance or voltage has been indirectly correlated with the extent of corrosion. Okay. So resistant, it shows the display in the resistance. The resistive probe is available with the integrated electronic for measurement of the 4-point method. There are this thing, and once this is the instrument. With this instrument, you provide connect it to the main your microprocessor, and then you run it on the surface. put the detergent water to make the surface conducting, so that your electrical current and your that should be able to pass through the system. Once it passes, so only then you will be able to receive the signals. So you make the concrete as a conducting surface area, and then I think this is the one. If the value of the resistance is 12 kilo ohms per centimeter, corrosion is impossible. If the value is between 8 to 12, corrosion is possible. If the value is less than 8, then corrosion is fairly certain. So from there you can conclude that okay, what is how much this thing. The main problem or limitation of this instrument is that it measures the resistivity in a very close reinforcement. Carbonation may affect the resistivity. It can't be used where ambient change in temperature is there and experienced operator is required to handle the equipment. This is a half cell potentiometer. This method is developed and widely used with the success probe, where the I think the where we are using the volt. This is what we called is the voltage reading we are taking. So you have the reference electrode, and this is how you can do it. Basically, in the this thing, this is a probe here. This is the probe, and it is a voltmeter, and this is connecting the one end is connecting to concrete surface. Otherwise, it is basically attached to your reinforcing bar. So once you current starts flowing, it will show some voltage reading. That voltage reading has been related with your corrosion, extent of corrosion. This is what copper sulfate electrode. What you do is you take a jar of with the distilled water, 1 liter distilled water, then put the 1 spoon of your copper sulfate solution, 40 gram of copper sulfate solution into the jar, and then you put that into your probe. Okay. Yeah. This thing, there is a cap is provided on this thing, and then it is connected to your cable, and okay. This is what your copper sulfate cell becomes. So what you do is you have proposed that is copper sulfate cell attached to the microprocessor of corrosion analyzer, and put it detergent or maybe some same copper sulfate solution on the surface, and then you connect it and other end to the this bar and take the readings. So readings will be voltage readings. So voltage reading means that okay, more negative than minus 0.35 volts, greater than 90% probability that the embedded steel is corroded. More positive than minus 0.2 volts, greater than 90% probability that steel is not corroded. But if the values are between 0.2 to 0.35, corrosion of the embedded steel is uncertain. So this is another test, is the core test. Core may be required to find out the depth of the carbonation, otherwise to also determine the strength of this thing. So there also you can see that you take the cores, there are the clamps, there is a core cutting machine. Once you drill machine is there, so this is through a drill material you operate it, and this is one. So basically the core strength strength by core cutting method will depend upon what is the diameter of the core. Higher is the diameter, better is your accuracy. Lower is the diameter, basically they will give the higher strength. If you say core of 50 mm as compared to 75 mm, your strength will be more of a 50 mm core as compared to your 75 mm core. So basically the more accurate size is about 100 mm, but then you are you have to see that what is the L by D ratio. Again, the our code 569 gives a correction method according to which you have to apply while you taking out the strength and determining the compressive strength by using this concrete core. Then direction of the drilling is again very important. So these are non-circuit techniques are interact in nature, therefore integral provider qualitative results are better. In old structure, expert knowledge is required. Care should be taken to avoid misleading results. Presence of cement slurry, honeycombing, hard aggregates, etc. can make the results influence the results. Obstruction is a fast technique which can be used for this purpose. So this is the one this thing. Let me see if I can show you just quickly other methods. Okay. Quickly, I will go through this presentation. So, depending upon the hardness method, we divide into two distinct surface hardness method, group A. Then you have the group B is the dynamic and vibration methods like your ultrasonic pulse velocity, acoustic emission, impact echo, transit this thing, sonic pulse velocity echo, cross hole logging system. Okay, then you have the magnetic methods. You have like we discussed this reinforcement detectors and cover meters. You have the electric methods where you have the half cell potentiometer, etc. And then you have the electromagnetic methods like radars, X-rays, gamma, this thing. Probability methods where we determine the permeability like your air, gas, water permeability. Then the partial density test, your penetration resistance test, Windsor probe, your pull-out test, pull-off test, break-off test, and core cutting. Because then chemical tests, okay, if you have to determine the carbonation, so what you do is you carry out the chemical test. You have to determine the your sulfate and chloride content. You have to carry out the chemical test basically. So you get this carbonation test is nothing but a sort of an indicator when we applied it on the concrete surface. Your concrete, depending upon its pH value, that color change take place. If it color from pink to it becomes colorless, that means your concrete is carbonated. Similarly, sulfate and chloride, you bring it to your lab samples, and then samples can be used in your environment lab with by using the titration method to determine sulfate and chloride. There is a standard method for that also. So that you can do that. You have a crack resistance, and okay, these are the properties. So if you say compressive strength determination, you are using Ramond hammer, pulse velocity, Windsor probe, ultrasonic pulse velocity, core test, Capco test, pull-out test, or any of the combination of these tests. Flexure strength can be determined by break-off test. The direct tensile strength is again determined by pull-off test. Concrete quality, homogeneity, honeycombing, voids, etc. are determined by using UPV, pulse echo, gamma ray radiography. Other damages like fire, blast, earthquake can be determined by using Ramond hammer, ultrasonic pulse velocity, and acoustic emission. Cracks and etc. can be determined by using ultrasonic pulse velocity, acoustic crack detector, X-ray radiography, gamma radiography, and crack scope. Basically, UPV can also be used to determine the crack depth also, or it can be determined to UPV ultrasonic pulse velocity can be used to determine the thickness of the two different layers. Like there is M20 grade of concrete or M40 grade of concrete, you can determine what is the depth of your thickness of your M20 grade of concrete, what is the thickness of your pile this thing. Then pile integrity test is again a pulse space test where you are using the travel of a pulse vibrations and then receiving it by using some sort of thing. What we do is the pile integrity method is in the pile head. Basically, we generate a pulse by hitting it with a vibrator, and we have a sort of a system which is attached to your pile, and those waves they travel down to the surface and picked up afterwards. So pile integrated, and this method is again can be used, and again this pile integrated is a very common method to test the quality of the piles where you are zoning the this thing, and you can see that. Then selection of non-substitute method depending upon your steel, location, cover size, rebar locator, corrosion. You have half cell potentiometer, polarization, condition assessment, your endoscope and bore scope, integrated and performance. You can see this load test, radar, acoustic emission test, etc. can be done. We already discussed the Ramond hammer. We are not going to discuss in detail. This is the ultrasonic pulse velocity test. Again, we have discussed it. This is the code which gives okay what is the quality of the concrete. This is the application part. Already we have discussed. Okay. This is a core cutting test which is done as per IS 516 and IS 199 and 456. And again, I have discussed that okay, minimum diameter of the core shall be 3 times core length of the this is 1.22 L by D ratio. Then then again the specimen brought from the site should be submerged in water for 48 hours, and then we have to see the minimum average equivalent concrete strength which should be greater than 85% of the design grade of the concrete, but no individual core shall have a strength less than 75%, which is again the same condition as we do it for the cube testing. Yeah. So core test determine in situ strength. They are also used for chemical test. They are also used for instructing water supply and plumbing lines. Carbonation test is again the, as I said, the normal pH value of concrete is around 13. Carbonation reduces the level of the pH, and corrosion may start pH when pH is about 11. Carbonation rate is high in dry weather, but possibility of the corrosion is less due to less moisture content. But phenolphthalein indicator is used to determine the depth of the carbonation. This is the nothing but what we use in the environment lab as an indicator, which were having some pink color, and as the medium changes from acidic to from alkaline to acidic medium, the color it becomes colorless. So same principle is being used here also. This is again we have discussed corrosion, the half cell potential meter. This is the closer mapping. One software is there which comes with your half cell potential meter, and with the help of this color coding you can find out which areas are prone to corrosion. Okay, I am zooming different. There are some advanced equipment also. Let me see. Okay, this is not that. Okay, I think maybe already it is 4:10, so maybe I will show you the some more instruments, advanced type of instruments in some of the other lectures. I think we can stop today, but if there are any questions or any this thing, you can discuss it. So anybody at different centers? कौन से सेंटर है कनेक्टेड? कर्नाटका.
Good evening, sir.
Yes, good evening.
Sir, I wanted to know how will you calculate the durability of a structure? So in I think Hoover Dam in USA, it is a probable life of 1,000 years. That is how do they calculate that one? Durability.
Durability of a structure. You can say life of a structure. Durability means, what do you say? Durability means that okay, we are assessing whatever methods we have discussed here is basically they are related to durability part only. Like present in situ strength, then your corrosion, and then your carbonation, and then your colloid. So basically, when we are discussing, we are trying to find the durability of a structure. Is basically what we are carrying out is all the tests has to be carried out. What is the present in situ strength? What is the quality of the concrete? Whether there are cracks available by using this ultrasonic pulse velocity, and then you carry out the chemical test to determine the depth of the carbonation. Whether carbonation has reached up to that level or not. So these are the tests basically which we are using to determine the durability. I think the whatever I said you call durability. Initially I said it is a conditional assessment. So basically these are the two parameters which we are using to determine the durability or maybe conditional assessment of the structure. Do you? I think
you're not audible.
Not audible.
Okay, sir. Sir, good evening. SPF Karnataka.
Yeah.
Sir, we were eager to hear the repair materials. Probably that was not covered in the today's session.
Yes, repair material we will have a separate session basically.
Okay, fine, sir.
Yes, we have a one session specially for the repair material only. So there we'll be covering the repair material.
Okay, fine. Because since it was mentioned in the schedule of today, we were eagerly waiting for that. That was not
Okay,
covered.
I think we changed the after discussing with your this thing. So we have changed your this things. The repair material we will be discussing I think in different session. We are discussing.
Fine. Yes. Thank you. Sir.
Excuse me, sir.
Yeah.
Sir, I would want to know how do you calculate the strength in tremie concreting? That is, when you're carrying out wet concreting, how will you calculate the strength? Now
Where?
During wet concreting, sir, how will you calculate the strength? Tremie concreting.
Tremie concreting.
Yes, sir. Then how will you come to know the strength attained in that after concreting?
I have not followed your question. You said that okay, when concreting is going on.
No, not when we have completed the concreting. How will
Yeah.
we come to know the strength attained by that concrete after curing?
After how you will attain that? Okay.
Yes, sir. Why? Because you have told on non-destructive methods and destructive methods.
Yeah.
So that the thing what I have told that does not fall in those two categories. So I just wanted to know.
Still your question is not clear to me. Let me explain to you. You said that okay, your concreting is concrete. After 28 days, you want to find the concrete strength at the site.
Yes,
That is
sir.
what?
Underwater, sir. Underwater. Strength.
Underwater.
Yes, that is the.
Okay. Underwater strength basically it is I think ultrasonic pulse velocity may not be the solution there. Yes, you have to take the course then. You have to take the core, or you may have to take that use the Windsor probe method. There you can, because there you can fire the your that pellet into your concrete. That can be used. Or otherwise, you may have to take the core basically. Take a concrete core, and then you can find out the strength basically using this core cutting method also.
Sir, but there the concrete curing will get affected. No, so then accurate results we will not be able to get. And how?
Concrete curing will get affected. No, it's not. Why? When you are taking the after 28 days, you take the course and you see that how much strength has developed. Maybe you take course and after at any age, that doesn't make any difference. Whenever you're taking the core, you can test it basically using that particular method. Then same problem you can say there is a one more method which is called the impact echo method. Impact echo method. What you do is there you have a single probe actually. That is also one method which is again based on the ultrasonic pulse velocity, but there you have a single probe. From the single probe you are judging the this thing. So you can use that pulse echo method for this purpose. The method is available. Recently we don't have that instrument with us, but recently we got a query, and when we inquired from this thing that the one basically underground this metro system was to be tested. So there that method was used because other surface was not available. So basically you can use that particular method, because there you need not go from the top surface. You can get the send the waves and receive it back, and then you can find out what is the strength of that particular this thing. So impact pulse echo method can be used for this purpose.
Okay, fine. Sir, one more query.
Yeah.
During testing of cement in India, we usually follow the visual testing. What you have told, that is just touching the concrete. But in abroad, what are the methods they are using? Why? Because I feel that they will not just believe by the visual methods.
Yeah, I mentioned one test as a maturity method.
Sorry, pardon?
I mentioned one method in my non-subject testing in presentation is maturity method.
Yes, sir.
Maturity method. So this method is nothing where you can basically, it is nothing like I can say you can compare it as simple thermometer. So that is inserted into your grid. That is inserted there, and you note down the temperature development there, and that temperature development is correlated with the strength development. and then you can yeah. So maturity method, and then also pull-out test method also, where you are using this. I think what you are doing, the insert at the time of completing, one disc is inserted into your concrete surface, and then a force is applied to pull out that disc during your this thing, and you will find out, okay, what is that, how much force is required to pull out that concrete. Even that can might be used for underground drilling also, because while concreting you have that also a disc, what you call the pull out method. You put that disc inside this thing, and then you determine the force to pull out that disc, and basically that can be correlated with the strength development also. So maturity method is the one, and then pull out method is the other one method, which can be used for while carrying out the concreting operations at the site to determine the development of the strength.
Sir, one more question.
Yes, please.
These NDT results, sir, NDT
Yeah.
results are relevant, and are they reliable?
That is what I said. If your instruments are properly calibrated, and your own they are done at a very in a proper way, then almost I will say they are 100% accurate.
Sometimes,
We have as I can tell you from my experience, we recently, I gave an example during presentation also. This has happened 2-3 times. We are using the rebound hammer, and the first question at the site, when we went at the site, they said, okay, you see, what is the accuracy of a rebound hammer? And then they brought a cube to us, and said, okay, you take a reading on this. We took the reading on that, and then they said, okay, no, tell me what will the strength. So we said strength will be plus minus this thing. So basically we are having a rebound hammer which we are keeping properly calibrated, and it is giving accurate results.
But one thing, sir, actually, last time, based on my experience, I'm just telling, those NDT results, I don't know whether it's properly calibrated or not, and based on that NDT results, then the particular portion, the particular structure was dismantled.
Okay.
Then afterwards, they came to know that they were having the sufficient strength. Maybe there may be some, there may not be some accuracy in the NDT tests.
Here I will say that, okay, this will again depend upon purpose of your objective of your investigation also. Investigation is to strengthen it. Then I think when we say UPV and all that, so your further strength results may be required, test may be required. You may have to, then I think if you are carry out further investigation, then they use this core cutting method also, or maybe some Capco test method also. For that purpose, basically accuracy level will depend upon your objective also.
According to me, sir, according to me, after having conducted these non-destructive tests, there are some more tests are to be conducted, so to confirm those results which have been given by the NDT. So that will be the better, and that serves as a more accurate values. Then
Yes.
that's what I want to say.
No, I do agree with you, because a purpose is that, okay, to what extent we want to go. It is just quality testing. Yes, we can find out that this quality testing is giving our results accurately, or we are achieving that quality or not. If it is a rehabilitation work, again we have to find out, okay, whether we have received this. Our objective is to reach the type of the grade we are looking at is M20 or so. Like if for example we say M20, we are getting at site is M15. So.
Okay, sir, thank you for the deliberations.
Yes.
So
Sir.
we are happy with the deliberation given by. We are very much thankful to that also. Thank you once again, sir. Thank you.
Thank you.
Sir.
Thank you.
Hello, sir.
Yeah. बोलिए. Yes, please.
Sir, first thank you for the excellent image group, sir, and also image collection of corrosion, sir. Sir, secondly, we want to know, sir. So in some of the images you have mentioned that one is structural cracks and some of the cracks which are for corrosion, sir. But how to differentiate in between that one, sir?
Come on, I have a question.
So how to differentiate between those two cracks?
How to?
So she said, unless and until we know the cause for failure, you cannot address.
Until unless you know the cause of failure.
we cannot address that you just said, no, sir, you mentioned.
नहीं मुझे actually not able to follow your question.
So how to differentiate between the corrosion cracks
हाँ and
structural cracks?
oh you differentiate between corrosion crack and
Structural cracks.
structural crack. Okay, you have to see the pattern of crack only. I think I have shown you the slides initially. Like if you are a shear cracks, they will be appearing in the diagonal in the shape. If you have a say fracture crack, so it will be like a straight crack or across the this thing or starting line will be straight. That the carbonation or corrosion crack, basically in case of a carbonation, will be straight along the bar. It is along the bar or at a say where the your reinforcing bar is provided. It is a very wherever you see where of the common this carbonation crack or carbon related corrosion crack, so generally it is along the bar where bar is provided, whereas in case of a colloid induced corrosion you will observe a small pitting, no crack otherwise you will observe, you will only observe a rust small spot of a rust or into the concrete surface. And in case of a, I said shear cracks are different, your fracture crack shape is different, your compression this thing different. If it is failing in tension, then the shape of the crack is different. So you with your experience and all that, you will be able to find out whether which type of a crack is there. I think it answers your question.
You told treating the rebars and recompleting is the way how we can repair that answer.
नहीं अगेन थोड़ा क्लोजली बोलिए माइक के, मुझे फिर नहीं आपकी आवाज नहीं आई क्लियर. योर वॉइस इज नॉट क्लियर.
Sir, you said for repairing that corrosion, sir.
Yeah.
Concrete corrosion. You said that by treating the rebars, recompleting is to be done, sir. Is that the only way, sir? Because in all the cases we cannot do such, sir.
Generally the carbonation, if you are asking me about carbonation related corrosion, that's generally your crack develops along the bar. Like if this is a column, you can say column, the crack will develop from bottom and will run to the top straight, basically in a straight line. I think that is what I followed your question. Maybe it answers. Voice नहीं आ रही इनकी मेरे ख्याल में.
Any other ways to treat corrosion, sir?
Can we? Yes. Any other?
Other ways to treat these corrosion issues.
Any other way to create?
Treat corrosion, sir. This corrosion issue.
Treat corrosion. Okay. How to treat corrosion related to this thing problem? Yes. I think this will be discussed maybe in this thing, but yes, what we do in the corrosion related problem is that okay, if it is a column or if it is a beam, so what you do is that okay, you remove all the carbonated concrete and take a hand and put it behind the bar when you have removed that thing and see that how much bar has corroded. If your hand should hold the bar, मतलब पीछे से जाके उसको hold करना चाहिए, ठीक है? It should be able to hold this thing, and that means all the concrete around that bar has been removed. Then what you do is you apply a anti-corrosive paint to the concrete. If the bar is has been corroded and its effective dia has been reduced say 50% or maybe that, if it is more than 50% or more than, then you remove basically that portion, basically that bar, and provide an additional bar there if it has been done. But if it is a section is good enough, that cross section, to put a anti-corrosive paint which are available in the market, and then you provide a micro concrete, maybe very provide a bonding agent on the surface, bonding agent on the existing concrete, and then provide the additional concrete maybe in the form of a micro concrete, because micro concrete is having a high strength, lesser permeability later on, and then afterwards you apply a anti-corrosive paint on the repaired surface. So then this work will work well. This will be a very effective solution. Maybe I may be having certain slides, I don't know. For the time being, Yes. Anything else in the meantime?
Sir, that way of treatment of rebars is not possible in all structural members, sir.
Yes, yes. Corrosion related treatment. Corrosion related treatment. Wherever you are having corrosion related treatment, there you are getting this sort of a problem.
No, sir, that way of treatment is not possible with all structural members.
Huh?
Hello.
Yes.
Hello.
Yes, yes. Boliye.
Hello.
Yes, please.
Good afternoon, sir.
Good afternoon.
Sir, I have a question. I'm calling from GEC Engineering College, Bhubaneswar, and the Engineering College.
Yeah.
So, I have a question. Suppose we don't have any instrument, so how will test the concrete? I mean, is there any field test for concrete?
If there any field test for concrete.
Field test for concrete means suppose we don't have any instrument.
Yeah.
So, is there any field test without any instrument? We conduct any test for concrete to know the strength or basic parameters?
You can basically then depend upon your visual examination only. That,
Okay.
like I said, okay, you have to see that go there whether if there is any cracks are there, any types of cracks are developing or not developing. So only thing that
No,
is
sir. Means my question is: there any field test for the fresh concrete?
field test for the fresh
Like
concrete,
fresh concrete,
hardened concrete or
like
fresh
the
concrete?
fresh
Hardened,
concrete, sir.
huh?
Fresh concrete.
Fresh concrete.
Yes.
No, you have fresh concrete means okay. What type of a test? For what purpose you want to test that fresh concrete? Yes, you have. What are the codes I have mentioned? Yes, you can. So for what purpose you basically want? I have not understood your question. Basically,
Like means consistency, workability means for the workability we are doing the slump test like this. If we don't have the slump test apparatus or to know the consistency of concrete, is there any field method?
that is only your from experience you can find out. Yes, but otherwise you cannot. It cannot be reliable this thing. But yes, maybe some experience you can see that okay, like masons they see that okay, it is having how much flowability is there. So that is you can, otherwise it is not an exact test basically by which you can say that okay, we can determine you are this thing. Not
Okay, thank you, sir.
right.
Hello.
Yeah.
I'm also calling from Gandhi Engineering College.
Okay.
And I want to know that if some existing member, concrete member, is affected by sulfate,
Okay.
then how can we recover it? What are the procedures to recover it?
Sulfate affected concrete, you mean to say?
Yes.
If it is a sulfate affected concrete, actually repairing a sulfate affected, basically only thing is you have to remove that part. It is difficult to whenever these things sulfates are there, so it is not possible basically. As far as I will say that if it is a deterioration to that extent, it is not. It will depend to what extent that deterioration has taken place. Basically, you can say, because if the chloride induced corrosion, there are chemicals available, there are repair materials available, which basically balance your this thing. So there are the certain type of a materials are there. Like if you say if it is sulfate resisting cement, so you remove the affected part type. If it is a sulfates are coming from the outside, then it is possible you remove that affected part where up to what extent the sulfates are affected, and then replace that part by a sulfate resisting cement, and by applying a bonding coat. And apply on the inner core concrete, you apply you repair it with the help of a sulfate resisting cement, so that it is possible. But if the sulfates are within the cement, then it may not be possible to repair this thing. So depending upon what is the source of your sulfates, you can carry out the repairs. Yeah. Okay, I think So, so we can call it a day today and see you tomorrow.